So, dear Lord, mighty God in heaven, we thank you for today. We thank you for the gift of life, Lord Father. We thank you that we've been able to attend this seminar, Lord Father. Father, we ask of you to protect us, guide us as we attend here, and may please give us knowledge, wisdom, and understanding in the lesson, Lord mighty God Father, in the mighty name of Jesus. Amen.
Okay. Thank you so much, Shekinah, for the word of prayer. Yesterday, we looked at the element of construct and we were concentrating at that part of, yesterday we concentrated mainly on the statistics part, and today we are going to start another element of construct. And I'm still, if you check very well, I'm looking at those the common ones that are appearing for many of the papers you are doing. So I'm going to concentrate on this element of construct today of patterns and algebra. I know many of you have tried out quite a number of them, but today our target, we are going to use 2 days to do this particular one because I want you to understand it right from the basics. So we are going to use 2 days, today and tomorrow is what we are going to mainly concentrate on. And then afterwards, we shall be able to proceed to another element. So today our element of construct is on patterns and algebra. So that's what we are going to look at today. And under patterns and algebra, these are the topics that you should expect. Remember, when they are setting a scenario question, they can easily combine 2 different topics. However, there are those ones that are a bit independent, whereby someone can easily set one scenario question. Now, when you look at item 2, the common part or the common topic that can be set is the topic of linear algebra. So if you check very well, you have noticed that there is a lot of linear programming whenever it comes to your item number 2. So today in our session, we are going to mainly concentrate on what we call linear programming. So under linear programming, when this question is set, it combines inequalities and regions. It combines equations of straight lines. So, and equations and inequalities. So it combines all these topics into one, and therefore you go on and you solve. So that is what we are going to mainly look at in today's session. Now, as we start, we need to first know what is linear programming? When we talk about linear programming, many of you are going to be making businesses in the future, or you are going to be setting up business. And one of your main target of setting up a business, it is to look out for profits. And how do you look out for profits? You must maximize your sales. So for anyone who comes up with a business is looking at how am I going to be able to make profits? So that process of that person coming up with obtaining the profits, we can be able to solve it using what we call linear programming. Now, when they talk about linear programming, the way you hear the word linear and then programming, it has two words. When I talk about linear means straight. So linear, it defines what we call the relationship between multiple variables. With degree 1. So linear means a straight. So here, when we are doing linear programming, we shall always expect to get what we call linear line or what we call straight lines. So here we are going to be forming equations that give us a straight line. You will never get a curve when it comes to linear programming. Now, when it comes to the word programming, Programming is a process of selecting. So it is a process of selecting the best solution. That's what you call programming. The process of selecting the best solution. Like we have said, here we are looking at which solution is the best that can maximize my profits. So the process of selecting the best solution from various alternatives. An example I can give you is that when you look at when it comes to transporting things from one place to another, always you have options, either to use trucks or to use lorries, either to use the bus or to use coaster. But in order for you to come up with the best alternative, then you need to use what you call linear programming. So when we talk about linear programming, we are going to look at that kind of process of us coming up with a solution from a list of alternatives that we have. So that's what we are going to be looking at when it comes to linear programming. And where do we apply them? Now you are going to expect your questions to come from any of these ones, from any of these 4 applications. When it comes to designing and manufacturing, you'll find a concept of linear programming. In our daily life, these are the common ones where we apply linear programming. So it can be applied in engineering. It can be applied when you are manufacturing. In manufacturing, we are asking ourselves, how can we get maximum profits? How can we minimize losses in a business? So that will come within the manufacturing. When it comes to energy industry, electric power systems, we can also use linear programming. But also when it comes to transport optimization, we shall find ourselves using the concept. So the common ones you are going to find very many numbers rotating about transport, rotating about manufacturing. That's where many of the numbers you are going to be looking at, that's where they're going to be based or centered. So when you are looking for profits and when you are looking for costs, minimizing and the rest of that. So under linear programming, there are 2 things you need to know. Either you are maximizing or you are minimizing. When it comes to time, you can ask yourself, how can I maximize the limited time that I have to my UNEB exams? In case it comes to minimizing, you ask yourself, how can I minimize the costs for the business? So there you are looking at those 2. So the question when it comes to linear programming, either you are maximizing or you are minimizing. And what are the key components of linear programming? There are basically 4 components when it comes to linear programming. One is what we call the decision variables. You coming up with a decision on which variables to use. When we talk about variables, a variable comes from the word varying. Varying is like changing. What are those things? Whenever you get your question, you ask yourself, what are those things that are going to be changing? What are they looking at that is changing? Is it the lorries and the taxis? Is it maybe time and this? So that is the decision variables. And the 2 decision variables we are going to look at, we are going to name them either as X or as Y. Then 2 is what we call constraints. In simple terms, constraints are what we call our inequalities that we are going to come up with. Then the data is the problem that has been set for you. Then the objective function, when they talk about the objective function, that is the function you are going to use to either maximize or minimize. So objective function is that kind of equation. It's okay, an expression or an equation that helps you to find out, are you either making a profit or are you making a loss, such that you can base on it in order for you to come up with a conclusion. So those are the basic things you need to know about linear programming. So how do we solve the linear programming problems? The first step is identify the variables you are going to use, formulate the objective function, write down the constraints, the non-negative, and then after use your graphical approach. So allow me now to start. How are we going to maximize our marks or the scores on linear programming? Now, the first one is you must always define the variables you are using. Please, they are not going to be defining for you that this is X, this is Y. By defining the variables, I mean that if you meet the problem, you ask yourself, what is changing in this problem? What is varying? What is it that this manufacturer or this person is looking at making that decision? So those are the variables. So define, say, in case the problem is about transportation, then say, let X represent the number of lorries. Let Y represent the number of this and this. So that's what we say, define the variables you are going to use. So don't just come out of the blend, say C and B without defining what they mean. And I want to be very clear on this, that whenever you are stating or whenever you are defining your variables, please let us stick to X and Y unless they have specified in the question that use these letters. Please avoid using letters. Let me say, you say, let L represent the lorries. Let's see, represent the cars. It is very correct you have defined them, but some of us are not yet used to know that X and Y we can use L or you can use C. So it is going to confuse you when you are plotting. You are asking yourself, where am I going to put L? Where am I going to put C? So I want us to concentrate on only relating two variables. Let it one be X and let the other be Y. Don't use any other letter for defining what your variables are. Always stick to let X represent this and let Y represent this. Number 2, always include the non-negative inequalities. When it comes to constraints, generate all your inequalities, all the possible inequalities, but please do not forget the non-negative inequality. The non-negative inequality means that you are going to say X can never be negative and Y can never be negative. At least that is one of the mark that you should always score, whether you have tried whether you know what to do or you don't know. The first step is define. That one you are going to get a score. Then after, write your non-negative inequalities that always X is greater or equal to 0, Y is greater or equal to 0. Whether they are relevant for that particular question or not, for you include them. Always those two, let them never miss whenever you are writing your inequalities. Always this one, you should just know it that always I must include them. X is greater or equal to 0, Y is greater or equal to 0. When it comes to constraints, I've told you constraints means the inequalities that you are going to be able to extract from your problem. Number 3, always let's have the objective function. And now I want you to emphasize that when it comes to the objective function, we have said that objective function is that function you are going to use to decide whether you should use more of this or less than that. Is that function you are going to use to find out how much profit are you making? What is the cost? That's what we call the objective function. And for this one, I want you always to define it clearly. In case the question is looking at you checking out how much money you are how much profits you can make from that particular business, then I want you to specify that profit is equal to, then you specify that maybe 30,000, maybe 30,000 X plus 40,000 Y. So specify the profit. In case it is in terms of sales, then you use the word sales is equal to, in case it is costs, then say costs is equal to, yes, like that. Do not just use the letters, say P, and then you say is equal to this. What is P representing? That's what you call defining all your variables that you are using. Then another one is that after extracting all your inequalities, please let's have the boundary lines. Some of you always go straight. Take an example, you have extracted and you have obtained X plus Y is less than or equal to 4. This is your inequality. After obtaining this, Since you are going to be drawing them on the graph, then I expect you that in your working space, you have the boundary line. The boundary line means that you are going to replace the inequality sign you have with an equal sign. So I expect you to have x plus y is equal to 4. So please take note of that. Okay. Then the next one is the table of coordinates. Now, let me use this now as an example. You have obtained your inequality. This is one of your inequalities you have. After writing for answering the part A, part B will always ask you, show the feasible region. Now, what you do, you show that now this inequality is going to transform into a boundary equation. So you'll come and say x plus y is equal to 4. When you are forming the boundary line, always, instead of having the inequality, you just put an equal sign. Now, what I mean by the table of coordinates, I want you to come and you draw your table very well. That my table is here. I have my x and I have my values of y. Then after, put the values of x you want, and then you proceed. After that, extract the coordinates. Some of you love plotting the way you are getting the values here, that these are my values, and many of you want to just plot them on the graph without extracting the coordinates. So extract the coordinate that my coordinate is 0, 4, and another coordinate is 4, 0 that I'm going to be plotting on my graph. So in case you have another coordinate, then also you bring it that my coordinate, I have another coordinate. So that is what you call extracting the coordinate. Then when it comes to the graph, yesterday we talked about the graph. I want to repeat. Now, when it comes to linear programming, the title still will be very key. So your title can be a graph showing the feasible region, a feasible region between maybe the number of lorries and this and this. Then don't forget to label your axes. And here I want to emphasize, when it comes to linear programming, your graphs are going to have, in case this is your graph, you'll put that this is my y-axis, this is my x-axis. Then specify, what do you have along the y-axis? In case y-axis you have, it is representing the cows, put cows, that these are cows. And here put, in case they are goats, you put goats. In case that's what you are looking for. Specify. And do not forget to have the demarcation. Demarcations, I told you, these simple lines that you label every after given period of time. Is it every after 2 centimeters or what? Then in case what you are labeling has units, then include the it where it is applicable. Now, when it comes to your lines, please do not cramp that always there must be bold lines or dotted lines. Always interpret the question very well. How do you determine whether it is a bold line or when it is a dotted line? So the things we look at when we are determining whether I'm going to draw using a bold line or dotted line. One, I want you to always to look at the inequality given. In case your inequality is greater than or equal to, or less than or equal to, here always we use a bold line. Here we use a straight line that is bold. Whenever you find that your inequality is greater than or less than, then here we use what we call dotted lines. So you always look at the inequalities you formed, and then you make a decision whether you are going to use a bold line or whether you are going to use a dotted line. But always do not forget that for your two axes, the x and the y, always for them, they must be bold lines, because our non-negative inequalities are always greater than or equal to. So bold lines, it means that that is part of the solution. It is inclusive. When we say x is greater than or equal to 2, it means that 2 is part of the solution. So here we are looking at values of x that are greater than 2, including 2 itself. So 2, 3, 4, and the rest of that. So there we use bold line. Bold line, it means that even when you are extracting your solution, that any point along that line is going to be included among your solution. But when it comes to dotted line, it means that it's not part of your solution. So whenever you are drawing your feasible region and you find that what is connecting, let me say you have drawn this line like this, you have drawn another one, and you have drawn another one, and you have finished to shade. Then when you are reading off your values for the feasible solution, we don't expect you to read any point from the dotted lines. So we expect you now, for such a case, extract coordinates that are within the region. Then I want also you now to define the region that you have left. So the region is what you call the unshaded region. So you define that what are you shading? Are you shading the unwanted? And at this level, always we recommend shading the unwanted region, the region that doesn't satisfy the inequality. Then many of you at times forget to label your equations. So here I'm saying that label the line as an equation, not an inequality. These lines you have drawn on your graph, in case it is x plus y is equal to 2, label it like this. Don't put inequality. This is wrong. Don't put an inequality. Put the exact line. And when it comes to an equation, you must have an equal sign. So say maybe x minus y is equal to 2. So it must have that an equal sign. In case you don't want write it like this, then for you can say this is going to be x minus 2 is equal to y. Any of those ones can work. But you don't put inequality by labeling your lines. Then also let's have neat shading. When you are shading, some of you at times shade badly. You have finished to draw everything, but you look at your shading when it is disorganized. So there you are going to miss out. Make sure your work is very, very neat at shading. Don't just shade anyhow. Have a pattern you are following to do the shading. Then please take note of number 9. Include the scale on your graph. What have you used? Include a scale. What does 1 centimeter on your graph represent? Say, for vertical axis, this is my vertical axis. 1 centimeter is equivalent to one trip taken by the lorry. 1 centimeter is equivalent to one cow. 1 centimeter is equivalent to this and this. So please make sure you include the scale on your graph. Then when it comes to let me show you a graph. Now this is an example of a complete graph. When you look at my graph, you can notice that one, I have all the features I've talked about. My graph has a title. This is my title. Don't underline, no need. And it's saying a graph showing the feasible region between the number of pickup and lorry trips. So that is my heading. Number 2, I've said include the scale. What does 1 centimeter represent? Now for this particular number, my 1 centimeter was representing one trip made by the pickup. Horizontally, 1 centimeter was represented. So include your scale. Then we have said label your axis very well, that this is my y-axis, and down here, you'll notice that here I have labeled my x-axis. Number 2, include what does the y-axis plot represent? That my y-axis plot represents the number of pickups. And what does my x-axis represent? It represents the number of lorries. But I want you, please don't use don't say like number of lorries. For you write in words, number of lorries. Do not abbreviate because these are not standard. So I used it here to show you that this one, you'll be penalized. Complete it and say number of pickups. Then when you look at my shading, it is very neat. Then I've said label your lines. In case the line is x is equal to y, label it that this line is equal to x, y. Do not say x greater than y. No, always use the line. So we expect you, this one is wrong. So we expect you to have an equal sign. Then shade appropriately. As long as you remain, in fact, even at times you can even say region. Region W is what we call the feasible region. You can name it that, or you can say the unshaded part, the unshaded region is what we call the feasible region. Or you can just put a letter and say W is equal to my feasible region. So there is no need for you to shade everything here on the graph. As long as you have obtained that feasible region, then have it. And also show clearly the points that you have plotted. So that is briefly about what we call the graph when it comes to linear programming. Then the last one is going to be on the conclusion when we are concluding or making our final remarks. Because already remember, we have said that for linear programming, they are asking you the decision that you can take among all the alternatives you have. So we expect you that write in statement, write in words. You can say that the maximum profits that can be obtained from the business is Ugandan shillings, maybe 30,000. And it occurs when this and this. It occurs when three trips of when the lorry takes 3 trips and the bus takes 2 trips. So that is what I'm saying by concluding with the figures included. Okay. Then here I've also reminded you, don't include for the combination or what we call the optimal points. Do not include the ones that are on the dotted line. But also I want you now, from today onwards, after you drawing your graph, I have drawn my graph like the way you are seeing this graph. Please, when you are coming up with to get the solutions, please have a table, draw a good table. And your table put optimal points. And what are optimal points? Those are points that are going to be, that you are going to base on to come up with a conclusion, say X, Y. Then extract them as coordinates. Now for this particular one, I can say I will extract 0 and 12. I can extract maybe 2 and 3. I can extract this. So write them as coordinates because when you are reading them here, you are reading them as coordinates. So you extract them as coordinates. So please do not forget that. So extract them as coordinates such that you can be able to get. Then here, when it comes to this part, this is where you're going to put your equation or what we call the objective function and say that my profit can be obtained by having 30,000 X plus 6,000 or Y. So that one, let it be very clear. Yes, Solomon. Yes, Solomon. Yes. Oh, Solomon, you are not clear. Solomon, you can type your question in the chat. Smart Elisha.
Yeah, my query was that when it comes to getting the coordinates, how do you format the table?
How do you form the table?
How do you form? Yeah, how do you draw it or how do you make it the one for the coordinates?
Oh, like, are you seeing the one I've drawn? I've drawn here sample.
Not really.
Okay, let me clear.
Mm.
So when you are forming, when you are drawing your table, I'll come, I draw like this. This is my table. Then I'm going to say optimal points. Optimal points, I write the word. Then in brackets, since I'm extracting XY, I write XY. Then this side, I'm going to say in case it is cells, I'll say cells is equal to the equation I formed, maybe 3,000 X plus maybe 6,000 Y. Then I cross the table. Then I extract the points that is 0, 12, maybe 2, 3, this and this. Then I keep on punching in these values into my cells. So I can say this is 3,000 X times 0 plus 6,000 times 12. Then I put the answer like that, like that. Hope that
Okay,
is okay.
thank you. Yeah, it is okay.
Okay. Okay. Now, when the number of optimal points are too many, do you have to write all of them? No. Now, when it comes to the optimal points, whenever you find that your boundary region is bounded by borrowed lines, always first check out on the corner points. So those corner points always give you the maximum or the minimum points. So in case you have drawn and you have remained, this is bold, 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 and you have shaded like this, like this, like this, like this, you have shaded. So these points here at the corners are the ones that are going to give you the maximum or the minimum point. Always, you'll find that these ones along, they will be the ones that in 90%, the ones to give you the maximum or the minimum points. Now, when it comes to here, don't have more than 10 things extracted. No, you can have a maximum of 6 or 7. So for you, what you do, in case it is bounded by borderlines, first look at the corners. That one should be your priority. Then you can sample at least 2 or 2 from the within the inside part of it. But in case it is bounded, let me say you have drawn like this, you have this as your borderline, and you have this. So, and you have shaded like this. You can notice that for this one, this is a dotted line. So you cannot have this point taken, you cannot have this point taken because it is joined by a dotted line, and for dotted line, it's not part of the solution. So meaning that your point you are going to extract this is going to be one of the points, then sample a few points from the borderline and some few from within the region. Okay.
Okay.
Bless.
Good morning, sir, and good morning, everyone. Sir,
Good
my
morning.
question is, with these optimal points, over optical points,
Optimal.
teacher, I'm lost. When we did the first table, the X and Y, and we were saying 0, then like you give it any other known, and like 0. So
now when
do we plot that, or we plot these points?
Oh, now optimal points are obtained after you have drawn, after you have plotted and shaded. The region that you remain with that is unshaded is the one you use to obtain the optimal points.
And then how do they help me?
They are the ones that you are going to use in order for you to find whether you have obtained profits or losses.
Oh,
like
okay, sir.
So they are the ones that you feed into the function you want to test whether it is giving you maximum or whether it is giving you minimum.
Okay, sir. Thank you.
Okay. Yes. Okay. Najina, that is very true. That is very true. Yes. Okay. We are going now to continue. Now, that is what now I want you to know. Now, let us start with the linear programming. Now, I want you to pay attention to the symbols that are going to be very common when it comes to linear programming. Now, linear programming, remember, we use only words. So I want you to pay attention to these words that they use. So the words that they use are very key in order for you to pass the question or to fail the question. So when you look at the first one is less than. So I know very well. Now for you, what do you want to know? I want you to know first know less than, that inequality that represents less than. In simple terms, the less than is your left hand. When you fold your left hand, you can notice that it is a very weak. So always that is the less than. Then when it comes to greater than, know these common ones. These are the very common ones. However, now when they bring in the English words, I want you to pay attention to those English words. When they say fewer than, when I say that the number, like when you look at this Zoom, I can say that the number of children that attend the morning prep is fewer than the number that attends the day lesson. Because you can notice that here we are less, so we are fewer than. We are less than. So that one, pay the word. In case you see fewer than, when you say the word lower than, smaller than, shorter than, below. When I say that, maybe Melissa is below 150 centimeters, it means that her height is less than 150. So here I will say, if I say Melissa is below 150 centimeters, I write it like this: less than 150. That means that her height doesn't go beyond 150. Then when I say greater than, other words we can use is more than. exceeds, larger than, longer than, above. When I say that maybe Shekinah is above maybe 180 centimeters, it means that her height is above 180. So it can be 180.5, 181, like that. When I say that your mom is going to give you pocket money above 10,000, it means that you are going to expect pocket money that is beyond 10,000, maybe 20,000, 30, or it can be even 10,000 and some additional fee. Then, when we say that greater than or equal to, I want you to pay attention. This is one of the common words. These two are very common. At least is a common word. So for you, the moment you see the word at least, what has to come to your mind is greater than or equal to. Now, I want you to take note. Whenever you find not, did not, if you find those statements that say not, did not, always remember you are going to have equal to. Whenever you find them, not more than, not less than, not this, that one, always expect to have either it can be greater than or equal to, or less than or equal to. Never can it be less than or greater than. The moment you find the word not than, not this, did not, so always expect to have an equal down. So meaning that one it will always be a bold line. Lucky, a question?
Okay, teacher, good morning.
Yes, good morning.
I don't know if I've taken you behind, but like when you're obtaining a scale for the inequalities, let's say they've given you big numbers just like 5,000. When you're obtaining the scale, how exactly do you do it? Because when I'm doing linear equation numbers and I use a smaller scale, as the same scale as the numbers they've given, then my values sort of exceed when I'm getting the maximum or the minimum. So I was wondering how they obtain the scale for linear equations.
Now, when it comes to the scale, what you do, you look at what you have plotted. Let me say here, you had plotted 0, 10, 20, this is 30. So here, when you notice here, when we are reporting, always better to report in terms of 1 centimeter. So here, you'll notice that your 1 centimeter is this is 1 centimeter. So here, 1 centimeter is equivalent to 5. So for this particular one, I will say 1 centimeter is representing 5 trips made by the pickup. In case here, let me say you had plotted 0, 100, this is 200, and this is 300. Still, I look for 1 centimeter. That 1 centimeter will be equivalent to 50. So I will say 1 centimeter is equivalent to 50 something.
So teacher, now I was wondering now to get that scale of like 30, because they've given you, let's say 3,000x plus 6,000y. You're just supposed to use, like, you can just use any scale you want and just use that as the coordinates to fill in
Yes.
Oh,
yes.
okay, thank you.
Yeah, but now what you need to remember now that at this level, don't expect those large values.
Yes.
You'll always have smaller values. In fact, they are going to be very small, very, very small values. Don't expect big ones, because when it comes to big ones, it's going to be complicated, and it means that it will need you to use other methods, other programming methods. So always expect something very small.
Thank you, teacher.
Okay. Bogele Mary Grace. Bogele. Okay. I'm failing to get Bogele. Bridget.
Good morning, teacher.
Yes, good morning.
So what if in your inequalities that the inequalities are high, so what would you do?
Oh, now when the inequalities are big, you reduce them. Take an example in case maybe you
Teacher,
have
even if when you reduce, like they still give you big values.
Oh,
How
then
would you
there
do it?
now in case they still give you big values, you
Yes.
adjust your scale here. Instead of using 1, 2, 3, 4, then you can use 5, 10, 15, 20, like that. on your graph.
Okay. Yes. Thanks.
Okay. Niche and KJ.
Good morning, sir.
Yes, good
Like,
morning.
if you miss out one inequality, are you marked wrong even though you get the correct answer?
Now, when you miss out one inequality, chances are high you may not be able to get the correct optimal points. So they are going to mark only what you have obtained correct. They will score you according to what you have been able to get, but they will not get the maximum points.
All right,
So
thank
when
you.
they're marking, yes, they mark in steps that you have this line, yes, they give you a mark. Okay. Then let me have Elijah.
Yes, thank you so much, sir. I was kindly requesting to ask about a question concerning obtaining a scale. If you obtained a scale of about 50, 100, 200, and so going on, if you've obtained a feasible region, which coordinates do you consider? Because now
Those
we
ones.
assume.
Now, those ones you have plotted, you read them the way you have them on your graph. That I used 50, you say 50 and 100. 60 and this. You read them the way they are. Okay. Grace, but like I want to give you hopes. Don't expect bigger values. Expect something very small. But in case you meet, God forbid, always read them the way they are. Read your graph the way you read your coordinates the way you have them on your graph.
Good
KJ,
morning, sir.
Yes, good morning.
Good morning, sir.
Yes, good morning.
I wanted to ask, what do you exactly shade? Because for me, in my mind's eyes, I thought that you shade that is needed.
Oh, now, that approach is also very fine, eh? But that one, that's why I said define the region. If you look at here, I told that define the unshaded region, whether it is wanted or unwanted. But I want to advise, many of the examiners or many of the people that mark your papers, they are used to the unwanted region. Are you getting it? Secondly,
Yes.
when you shade the wanted region, you are going to cover, let me say you have shaded this, as you have shaded this region that is wanted. Reading points mathematically, it is not easy because you end up covering the points that you want to read from it. So that's why we advise to shade the unwanted region, such that you can be able to read off the points. Because if you shade this region that you want, it means you cannot be able to read off the coordinates. You have covered them. So that's why I advise you shade the unwanted region, the region that doesn't satisfy the inequality, unless the question has specified. Hope that
Okay,
is
sir.
fine. Okay. Tracy and Emma. Yes.
Good morning, sir.
Yes, good morning.
Master, I was asking, what if we get points? What if we get points when there is some decimal? How do we tackle that?
Now, whenever you get points, I want to advise, I'm going to show you, we are going to do quite a number of them. Always avoid getting points. In case you find that coordinate where you are getting a point, try to look out for another coordinate that doesn't give you a point. But in case you get a point and you are time bad, then write that coordinate to one decimal point and then plot it. But for optimal points, never read off points. Read out only exact numbers. What's unmute?
Yes,
Yes.
good morning.
Good morning.
No, for me, I'm just asking. For example, you've got a point whereby it is at the place where the dotted line and the solid line meet. You read it?
No, you don't read it.
Okay, thank you.
Okay. Okay, I think I have exhausted those questions. So let me just look in the chat briefly. Okay, how do you minimize? That one we are going to look at it. Okay, Appeal, I'm going to look at the graph. Okay, we are going to look at all those things. Let us first finish. Now, these are the words I want you to master. So when it comes to less than, please, this word is very common, at most. So whenever they say at most 10,000, it means that your parent can never give you anything above 10,000 as your pocket money. So when you say my mom gave me at most 10,000 as pocket money, it means that your mom, the maximum amount she gave you was 10,000, but also there are possibilities that she gave you less than that. So check out the word at most, less than or equal to, at least greater than or equal to. But also do not forget, I've told you, when you find the word not does not what? Those ones, they will go with this equal sign. Please check out on those ones. Okay. Now we are going to go through the first activity we are doing, we are going to do about 9 problems. And my major area of concentration, I want to ensure that each one of you can be in position to extract the inequalities correctly. After that, we shall go on and do the plotting. But I want first to ensure that each one of you, however difficult, however complicated the problem is, when you can be able to identify or to extract the inequalities, because that is what is very important. The moment you fail to extract the inequalities, it means you can never pass that number. So now that's what we are going to start. So the next activity is going to be forming the inequalities from the different scenarios. The moment you understand that, then we are going to be very good to go. Now, what do I want you always to do? The moment you find the inequality, the moment you find the problem, what are you going to do? I want you to always first highlight the mathematical words. Read the scenario more than one time and then identify the keywords. For this particular one, they're telling us that a furniture company has 120,000 to invest in making tables and chairs. It costs 20,000 to make each table and 12,000 to make each chair. The company has a storage space of at least, now you have met a mathematical word, underline that word, at least 8 items altogether. Each table yields a profit of 80,000 and each chair a profit of this. Now, this is where many of you at times find it hard. One, failing to rate. How do you find out what am I going to rate on? To find out what you are going to rate, I want you always to pay attention to the question that is asking you to maximize or minimize. That question should give you the hint which things you are going to rate. So when you read through the question, it's saying that find how many tables and chairs should be made. So meaning that the purpose for this company is to find out how can they maximize the number of tables and the chairs such that they get maximum profits. So here, what is changing are the number of tables and the number of chairs, meaning that whenever the tables and the chairs change, it means that the company is going to either obtain a profit or to obtain the loss. But since they want to get the profit, they're asking, how can we play with the tables and chairs in order for us to come up with something? So meaning that here, what you are going to vary or what you are going to rate is the tables and the chairs. So the first thing we have said when it comes to linear programming, first rate. So you are going to say, let X represent the number of tables. Let Y represent the number of chairs. That should always be your opening statement. And we have said always use XY. Please don't use let T, let C. It is correct, but it's going to give you hard time plotting. But do not forget, I want to remind you, the people who are going to score you, they may not think the way you are going to think. So please use X and Y to be on an advantage. Now, after that, I want you to now to summarize. I always encourage summarizing your work. Now, when you are making your summary, I want you to take note that after you identifying the things that are changing, you are changing the table and the chairs. So for me, I always encourage having a simple table. In your simple table, you are going to have your tables. These are the tables, and these are the chairs. So the things that are changing is what you are going to put here, that the tables and the chairs are changing. Then you read the question again because you are taking a summary. Now, they are telling us that a furniture company has 120,000 to invest in making tables and chairs. Now, when they mention that that is what the company has, when you have, let me say, when you have pocket money of 120,000, it means that it can't go beyond that. It means that that is the maximum amount you have. So when they tell that someone has that, now here you need to know that this is the maximum. It can't go beyond that. And whenever you find that that is the maximum, you ask yourself, which inequality goes with the maximum? Maximum, in case I say that is 120,000, it cannot go beyond that. So that means your inequality that should come to your mind is less than or equal to. Whenever you say that that is what someone has, the inequality that will come to your mind is less than or equal to. So it can't go beyond that. So you have to pay attention to it. Hope we are fine on that. Okay, now after that, you continue reading. It costs 20,000 to make each table and 12,000 to make each chair. What are you going to do? You are going to put here up, I'm still summarizing, the cost of manufacturing. Now, after putting the cost of manufacturing, I'm going to ask myself, what are we manufacturing? That we are manufacturing each table. This is the law for the table. Anything about the table, I'll put it in this law. So I'll put here 20,000 for manufacturing a table. Then I'll put 12,000 to make each chair. Then I will come here and I say, this is 12,000 for making a chair. Then down here is where I put my costs. But what does the company have in total? That the company has 120,000 in total. So that is, I'm making it a summary. Anything here is about the cost. Vertically, you are not saying it is a cost. Now I've interpreted up to this point. Then I continue. The company has a storage space. Now here I'm going to talk about the space that is available. Available space. Available space. The company has a storage space of at least 8 items altogether. Now, when they say altogether, it means that when you combine the table, the space to be occupied by the table, and the space to be occupied by the chair, altogether, the total must give you 8. But we have said at least, meaning that when I combine what I have for the table and what I have for the chair, I must get 8. So meaning that here, they have the same digits. That is the meaning. And now that is the interpretation for the available space. Then you continue. Each table yields a profit of 80,000 and each chair yields a profit of 45. Then I'm going to come here and I say profit. We call it profit maximization. How much profit is the company? Then you say for the table, it will take a profit of 80,000. For the chair, we'll take a profit of 45,000. Now, what gives you the profit maximization is what we call our objective function. That function you are going to use, what you use to obtain to come up with the solution, to come up with the possible alternative is what we call the objective function. So this last one, since it's the one we are going to use to decide whether we are getting a profit or loss, is what we call the objective function. So this one here is what we call the objective function. Now I'm going to come and I form my inequalities. The first inequality I'm going to form, I'm going to say cost of manufacturing. And for the cost of manufacturing, I've said each table, for the table I'm using X. For the chair, I'm using Y. So I'm going to add everything I have in this column. So you say 20,000 X plus 12,000 Y. But since we say that the company has 120,000, that money should not be, it must be less than or equal to 120,000. And that is my first inequality for the cost of manufacturing. Then I'm going to first go to the second one. For the second inequality is the available space. I check out the available space. Now, when I come to the available space, I'm going to ask myself, they have told us that the company has a storage of at least 8 items, meaning that when they get the chairs they are making and the tables they are making, the space that they occupy shouldn't take more than 8 items. So I will say X, the tables, when I add on the chairs, that space should be at least, should take on at least 8 items. So meaning, at least we say that is greater than or equal to. So I will come and I say greater than or equal to 8. Then the third inequality I'm going to form here, since I don't have another I have other inequalities, is what we call the non-negativity. And non-negativity means that you cannot have negative tables, you cannot have negative chairs. So you say the non-negative inequalities, or you can say that the number of tables and chairs cannot be negative. Then I will say my X is greater than or equal to 0 and my Y is greater than or equal to 0. Then another inequality that I'm going to form is going to be now the one for objective function, because we want all the possible mathematical statements we can form. Now I come and I say my profit maximization. You check in the chart, what do they want? They want you to maximize the profits. So in order for us to maximize the profit, I will come and say that for profit, in order for me to get the profit I get on the table is 80,000, but the table is X. So I'll come and I say 80,000 X plus 40,000 Y. And now that is my profit. And here in brackets, feel free to put in X and Y. Now, those are all the possible mathematical statements we can get. Kindly let me know. I want to read through the chart and see whether we're on the same. In case you have understood how we have come up with that, kindly indicate in the chat that we are together. Up to and available, that is like the maximum someone has. So when they say available amount, kg, that is what you have. That is the maximum. You can't go beyond what you have. Yes, we said when you find that negative thing that does not, it goes with equal sign. At most, okay. Okay. Okay, I'm just reading through the chat. I think we are together. We are together. We are together. Okay. 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 Yes. Okay. Now that is the first number. So once you extract that, the rest of the things are going to be very, very fine together. So I want to repeat, when the objective function, you first read through the question and then you know what you are finding. Is it about sales? Is it about profit? Is it about costs? So here they wanted us to calculate the maximum profit, meaning we want to maximize the profits. So those are your inequalities. Then when it comes to these big ones, first avoid reducing it because they want you to write it the way you have it in the question. Before you reduce it, when it comes to reducing, I will advise reduce at the end when you are going to do the plotting. Yes, Smart Elisha.
Yeah, I was asking about this last part of the profit part whereby you say that you can put X and Y in brackets. Does it end there whereby you say the 80X plus 45Y?
Yes, that is the function. Meaning that for any combination you are going to obtain for the tables and chairs, where there is X, you know that those are tables. Where there is Y, those are chairs. So you will just be substituting. Where there is X, you put the tables. Where there is Y, you put the number of chairs you have got.
And also about this last column that you wrote, this last column that says profit maximum, something of that kind. I didn't understand that part.
This is
Yeah,
profit maximization. Now, because remember we have said that the intention of us doing linear programming, we want to find out, are we making profits or we are making losses? Should we proceed with the business or we should close it? Should we find new strategies or not? So now that function or that equation that you use to determine that is what we call the profit maximization, or what we are calling the objective function. So always you look out for that particular one that you are going to use to come up with a decision.
Okay, I've now got you.
Okay, Victoria.
Good morning, teacher Stevie.
Yes.
Stefan.
Good morning.
My question is that how comes on the profits you have not put the total?
Oh, because we don't know the total profits you are going to obtain from the business. And that's what we want to find out by solving the number.
I thought we are also going to add it as we added on the cost of number.
Now here, manufacture. Okay, now to obtain the profit, Victoria, you must first know how many tables and how many chairs you are manufacturing. But when you look at this number, we don't know how many chairs and how many tables is the company making. So in order for us to know them, that is when we go on to solve the number to draw. Are you getting it? So
yes,
your
so teacher, what you mean? What you mean in the line of total on this side of the profit, we don't include anything. We leave it blank.
Yes, you leave it blank. You don't include anything. The answer for you to get that profit, those are the values, the optimal values we said you are going to obtain from your graph. You want to know how many and which combination is giving you a bigger profit. Is it when you manufacture 5 and 6? Is it 2 and 4? Like that.
Okay, thank you.
Okay. What's and Ramadan?
Yeah, for me, I'm asking this part, the first part of rating. For example, if the examiner's guide is that X to represent the number of tables and Y to represent the number of chairs, what if for me I've interchanged? Will the graphs look alike or they will be totally different? And if they are different, is mine considered?
Yes, the graphs are going to be different, but now this is what I'm going to advise. Read the question very well. I always advise that what they start with, let it be your X. What they end with, let it be your Y. Is that fine?
Okay. Yes, thank you.
So first check out what have they started with, that they have started with the tables and then chairs. So let it be X and then the other one be your Y. Okay. Okay. Ramadan, I think we have answered you. Guilds? Okay. I think now we are going to go to another number. So another number, we have activity 2. Now, still for this particular activity, the first read through, they are telling us that Anne has been sent to the nearby supermarket to buy some apples and oranges. Apples cost 500 each and oranges cost 250 each. She's given only 2,000. I want you to mark that word, only 2,000. When you have only 2,000, it means, because now only, it means that in your pocket, you don't have anything more than that. And whenever they say only, it means that is the maximum you have. So for that particular one, the inequality that should come into your mind is less than or equal to. Only, it is not beyond that. To spend, she must not buy more than. I've told you, always check out whenever you find a word, not more than. What has to come into your mind? That I'm going to use a equal sign somewhere, equal to or equal something. Not more than 2 apples. And she must buy at least 4 oranges. She must also buy at least 6 fruits all together because her family has 6 members. So still I've said the first thing you do, let some, but in order for you to read through what does the question want, because that's where you're going to obtain which variables you are going to let. So when you read through, they're asking us that find how many apples and oranges. So meaning that the intention of the family is to see that Anne can bring a balance of apples and oranges. So the things that are going to change in order for her to come up with a decision to find out what she's going to purchase is going to be the changes in the apples and the changes in the oranges. Meaning that here now we are going to say that I've told you now here always it is good practice. What has come first is what you should let. Let X represent the number of apples. For you write in words, for me I'm abbreviating a bit. Let Y represent the number of, here she's buying also oranges. That is the first step. Oranges. Yes, Chilabo. Yes.
I'd like to know if we're supposed to use for the x is equal to 0, not 0. Why do we use x greater than or equal to x is
Okay. Okay, I've not gotten you well, but I think I've heard something. Why do we use greater than or equal to? The reason why we use greater than or equal to is to show that we cannot have negative things. Like for any person who is into business, you are not aiming at obtaining losses in a business. So you getting negatives, it means you are making losses. And someone cannot come up with a business and say why you are coming up with that idea is you want to obtain losses. Number 2 is that when we say X is greater than or equal to 0, it is an indicator to show us that the lowest you should obtain here greater than or equal to 0. It means that your set can have a 0, 1, or and the rest. Meaning that the smallest you can obtain is 0. And obtaining 0 meaning that you may decide not to buy. In case, let me use this example of apple and orange, that the worst decision I can make is not for me to buy an apple. That is the 0, the meaning of the 0. So that's why we put greater than or equal to. But when you say X is greater than 0, this one is an indicator that there are no chances that you cannot manufacture, like you cannot buy, you may not buy an apple at all. Yet that opportunity can happen whereby you don't buy an apple at all. So we need to include the 0 because chances can be that in order for you to make a profit, you can decide not to buy this thing completely and then you buy the other thing. Yes. Okay, now let us first summarize our table. Yes, but I did get your question well. You were breaking a bit. Okay, now we go to the summarize. So I've told you, after you knowing what you have read, summarize in a simple table. So I'm going to have my simple table. In my simple table, the things that are varying, that are going to change, I have the apples, I have the oranges. So I read the question again. An apple costs, so I'm going to first write here, the cost. An apple is costing 500 each. An orange is costing 250. Then I come. Have they given me the total amount this person has? That yes. What is the total? The total that this person has only 2,000. We have said that when they say only 2,000, it means that that is the maximum. It is not beyond that. So I'll have 2,000. That is the cost of buying. I continue. She must not buy more than 2 apples. So what does it mean? Here, the apples shouldn't be more than 2. She must buy at least 4 oranges. She must also buy at least 6 fruits altogether. Then here it says fruits to be bought. It means that they are telling us that when you combine the apples and the oranges all together, you must be able to obtain 6 fruits because each member at home must get a fruit. That is the meaning. Then you continue. She must also buy at least 6 because her family has 6 members. Then they're asking you, find how many apples and oranges she should be purchased so as to minimize her expenditure while maximizing the purchases. Now, the next function we are going to have here is going to be, how do we minimize expenditure? How do we minimize expenditure? And how do we maximize the purchase? Meaning that now we are going to form our cost, or what we call the expenditure. You can call it the expenditure. You can call it the costs. How are we going to maximize it? Now, in order for us to maximize it, now here you must reason very well that for this particular one, in order for you to maximize or to minimize, it will depend on the cost of the apples, how much the apple is costing and how much the orange is costing. So I'm going to come here and let's say an apple is for 500, an orange is for 250. So in order for me to minimize the expenditure, it will depend on the price of these ones. So that means that under my cost, I'll have 500 and I'll have 250. Because for this particular one question, we are not looking for profits or we are not looking for anything. And whenever we are not looking for profits, it means that we shall use the prices, the price for each of those particular items. Now I'm going to come and now I write my inequalities. The first one, I'm going to write the inequality for cost of buying the items. Now the cost of buying, I have apples. We said apples are X. So I write 500X, the whole of this table, plus 250Y. But they told us not more than 2,000. So I would say less than or equal to 2,000. Then after that, I come to this next statement because some statements you may not be able to summarize them in the table. Then the next statement, she must not buy more than 2. I told you the moment you see not more than, it doesn't go beyond 2. The maximum is 2. And I told you whenever you find not more than, then the inequality should have an equal. So now here you say not more than 2 apples. Now, not more than 2 apples, it means it must be less than or equal to. So I write apples is represented by X. I write X less than or equal to 2. Then I continue. And she must buy at least 4 oranges. Then I say at least 4 oranges. Now, at least 4 oranges, we say the word at least, it means that is the minimum. When they say at least, when you say at least that at least in this math paper, I must get an 80. It means that the lowest mark you can get is an 80. So you'll come and say at least 4 oranges. So you say oranges is represented by Y. So you say Y is greater than or equal to 4. Then you go to the next one. She must also buy at least 6 fruits altogether. the total number of fruits to be bought. Here, we have already summarized it. Then you say 6 fruits altogether. It means that when you add the number of apples bought plus the number of oranges bought, it means that the number of fruits should be above 6. Above or equal to 6. Then that is the last inequality. Then you come to the cost. Now you will say the purchase, or you can call it the cost or the expenditure. It is up to you. So I'll say now the cost, and I will put X and I will put Y. Then what is the cost? Then I will say it is going to be 500X plus 250Y. Now the total amount you get here is what you are going to use or to base on to know whether I should buy more of this or this. Because what is varying, what is going to be varying are the number of apples and the oranges, and they are determined by the price. So in case you buy 2 oranges and 2 apples, you ask yourself, how much money am I spending? And then you make a decision. Will this option be the best? So now these are the inequalities, or these are the mathematical statements that we can obtain. Okay, let me hope that is fine. Kindly let me know in the chat whether that is fine. In the chat. Yes, let me know in the chat. We have said only means that is the maximum, and that one we use less than or equal to. Yes, it is less than. It is less than. Yes. On the cost, yes, it is less than. It is less than. Okay. Okay. Yeah, so for the cost of buying, it is less than or equal to 2,000 because they told us only, so it is the maximum. Okay, I want us to first extract the inequalities. Allow me to go to the next one. Now, allow me now to increase maybe on the speed a bit. Now, we have the activity 3. I've said, now, the higher we go, the more they are going to be a bit more, they require a lot of some kind of reasoning. Yes, we are going to look at the graphs. Don't worry. We are going to look at everything. But the most important thing is us knowing how to extract. Now, they're telling us that a store wants to liquidate 200 shirts and 100 pair of pants from their last season. They have decided to put together 2 offers, A and B. Offer A is a package of 1 shirt and a pair of pants, which will sell for this. Offer B is a package of 3 shirts and a pair of pants, which will sell for this. The store does not want to sell less than 20 packages of offer A and less than 20 of this. How many packages of each do they have to deal with? Now, I've told that it is the question that is going to guide you on what you are going to rate. Now, when you look at the question, they want us to maximize the packages of each. When you read the question now, we have 2 packages. We have package A and package B, meaning that now when you are rating, you are going to be rating the packages. You don't rate the shirts and the pants. That's where I want you now to understand. Because some of you may rush and you can say, let me rate the shirts. Let me rate this and this. No. Please, you must pay attention. So what we are going to rate, because the question wants us to maximize the packages, I'm going to say, let X represent the number of packages of offer A. Let Y represent the number of packages of offer B. That is the first thing you need to understand. Then after, summarize. Now, after knowing that what is changing is the number of packages. So I'm going to say, this is my package A, and this is my package B. This is where many of you go off because you fail to understand what you are going to rate. Then you read the question again. Now, the question is telling us that a store wants to liquidate 200 shirts and 100 pairs of pants. from their last season, they have decided to put together two offers, A and B. Offer A is a package of one shirt and a pair of pants. Now, what do you need to know? You need to know that we have two things. We have shirts, one, and we have the pants. Hope that is okay. We have the shirts and we have the pants. When you look at offer A, has a package of one shirt. So where there is package A, I'm going to put the one shirt. And a pair of pants. So a pair of pants, I'm also going to come to pants, I put a pair. One pair. Then I go, which will sell for Uganda shillings? 30,000. Now, that means that for this package, the cost or the sales, I can say the sales, is going to be 30,000. I'm summarizing. Then I continue. Offer B is a package of 3 shirts. So I will come to package B, I put 3 shirts. And a pair of pants. A pair of pants, I put 1. Which will sell for Uganda shillings 50,000. So here the sales will be 50,000. I'm summarizing the table. The store does not want to sell less than 20 packages of offer A. Hope that is okay. They don't want to sell less than 20 packages of offer A and less than 10 of offer B. Now that's where I want you to understand. Now you're going to first come and ask yourself, what is the total? A store wants to liquidate 200 shirts, meaning the total number of shirts, when you add the number of shirts of package A and package B, is 200. When you go to the pants of package A and package B, the total is 100. Now, that is the table that I have summarized. Now, these additional statements are what you are going to add on. Because what you have laid is the number of package of offer A. We are not going to include these ones in that. So these are like the opening statements. So I'm going to come and I start my inequality. I'm going to start with the shirts. I will say shirts. Now for the shirts, I'm going to say package A is X. So this one being 1, I will say 1X plus package B is 3Y. But what does the company have? The company has 200 shirts, meaning that is the maximum the company has. It doesn't have more than that. So I'll come and I say less than or equal to 200. Now, there is no need for you to indicate X. So for you can eliminate the X. So I can just say X plus 3Y is less than or equal to 200. Then I go to pants. Then when I go to pants, I'll say 1 package of pants, 1 package for B. So I'll say X plus Y. But the company has how many? 100 pair of pants. So that is the maximum. So I'll say less than or equal to 100. So this is my first one. This is the second one. Then after that, I'll come and I say I add on that the store does not want to sell less than 20 packages of offer A. So they don't want to sell less than 20. What does it mean? It means that the minimum they should sell. I told the moment you see the notes, it must have an equal. So they does not want to sell less than 20. So I'll say less, that means of package A is X. So it means that the minimum should be 20. So I'll say X is greater than or equal to 20. Then, and less than 10 of offer B. And then I will say for B now, it will be Y is greater than or equal to 10. Now, after that, I'll come, but they want to maximize the money. So that is maximization of their sales. So I'll say to get the maximum sales, which is X and Y, I have it. For package A, it is 30,000. So I'll say, this is going to be 30,000 of X plus 50,000 of Y. And now those are my mathematical statements. Kindly let me know in the chat whether we are together. But let me pick some few hands. Oh, we are not together. Okay, let me first. Yes, Tessa. Tessa?
Teacher, on the inequality for does not want to sell less than 20 packages. I thought it would be less or equal to 20 and less
Does
or
not
equal to
what?
10.
Does not what?
Want to sell less than.
Now, you don't go off. Take an example. Let us use real life. When you have a shop and your target, you say, let me use Max. When you say that I don't want to score less than 80, what marks are you expecting to score?
80 and above.
8 and above. So that's why we are using that.
Thank you.
Okay. Trevor?
Yes, on here, on this inequality for Y, when they said that offer and less than 10, and I'm seeing like you're putting there like less than or equal to, and I've said that only less than, there is no equal to.
Now, here we shall bring in the English. Why? They told that the store does not want to sell. Now, that is like one statement. They're using the word.
Offer B.
Yes, that's what I'm saying. So, like here, the store does not want to. Now, first eliminate this. First eliminate this, and you remove the word.
Yes.
So that is like so it is like the store does not want to sell less than 10 of offer B. Are you getting it? So it has been added, the moment you see the word and it's like a continuation of one statement.
Oh, okay.
Yes. And remember, even you, okay. Ramadan. Oh, Ramadan. Imran. Elisha. I don't know whether I know him. Yes, Imran?
Excuse me, sir.
Yes.
I'm going to take you back activity too, but there is where I think you made a mistake in the summary. The fruits to be bought. Instead of placing the, because they said that apples, they said that she must not buy more than 2 apples. I thought that you're going to put the number of apples that she must not buy in that table, and then after add them like 2x plus 4y less than or equal, greater than or equal to 6.
She should not buy?
She must not buy more than 2 apples and at least 4 oranges. I thought that you put the 2 under the fruits and also the 4, whereby you will say 2x plus 4y greater than or equal to 6.
Now, whenever you find statements being where you have and, those are 2 different statements. Number 2, when you look at that statement, it has 2 different inequalities, and you cannot combine 2 different inequalities. You cannot combine more than, not more than, and at least, because those are 2 different inequalities. So you cannot have 2 different inequalities in one statement. Are you getting it?
Yes.
Yes.
So
that's why.
So whenever there is a conjunction, there are always 2 inequalities.
Yes, you separate the 2.
Okay, thank you, sir.
Okay. I want to take on the last question. Yes, Elisha?
So, sir, what I was asking about was these non-negative inequalities. Like, when are you supposed to know that here, like here, I'm supposed to apply the non-negative inequalities or not? Because according to some activities, like activity 3, and maybe activity 2, yeah, he didn't apply them, so I'm not
No,
kind of
okay,
understanding that part.
Okay, I've just left them, but include them everywhere. Include those
Okay, sir.
non-negative everywhere. Yes.
Okay.
Okay, I'm seeing Favor. Favor, I'm seeing here in the chat, you are saying something. I don't know which number. Favor, can you raise your hand? There is an error on the number of packet of Y to be bought. I suppose that should be Y less than 10, not Y greater or equal to 10. Oh, Favor, why do you say so? Okay, Favor, your hand is up. Yes?
Particularly the question says that the store does not, okay, the store does not want to sell less than 10. Okay, then it should be Y is greater. Okay, yeah, that's correct. I had not seen the initial does not quantify, so that's why I hadn't understood.
Oh, okay. Terms, TUMS.
Yes, teacher. There is someone who asked about the non-negative inequalities, and you told him that you apply them everywhere. But if you have already said that x is less than or equal to 20, why would it be that x is more than or equal to 0 again?
Okay, why? Okay, why I'm telling you to include them everywhere is that those two inequalities apply everywhere. But here, at some of you, you may not be able to reason at the point where you are not going to use them and where you are not going to use them. But here it is very okay. For you, what I want is just apply them, just put them there, whether they are relevant or not. And I said that early on. So for you, apply them there. In case they want them, they will mark them because there is no penalty, whether you have included or not.
If someone writes both of them, means them end up floating, like shading.
Yeah, remember always, here the reason is that one, you cannot have negative shirts, you cannot have negative pants. That's why we want to include them. They apply everywhere. You cannot have negative. You cannot make a business and say, for me, I want to get losses. That's why we say include the non-negativity.
Yeah. I was asking, like, you wrote x is more than or equal to 20. And if someone again writes that and then he writes x is more than or equal to 0, when there are two of them with the same question.
Okay, now what I'm saying is when they are marking, when they are marking is that if you can reason like that, the way you are reasoning, that one is very okay. So for this particular one, when they are going to be marking you, they will mark this inequality. They mark the major ones. So the major inequality is this, and this. So these ones, they will not award you. There are numbers where they are not applicable, and there are numbers where it is applicable. But for me, just what I want you is not to miss out them, yet you may leave them when you may leave them for some numbers out, yet they are necessary. And you may not put them somewhere where they are not necessary. So to be on a safer side, for you just put, but for this particular one we are doing, they are irrelevant. Is that fine? Yeah. But also I want you to know is that if you don't include them, there are chances that you may draw your graph. You may draw your graph and you don't shade this region. Yet that region should always be shaded. So meaning if you don't have them, don't shade this region, of which will make your graph wrong because you cannot have negative.
Yes, teacher.
Hope you are.
Thank you, teacher.
Okay. Okay, I think let's go to another number. KJ asks, as we go to another number, let's be reading through that number I've displayed as KJ asks.
I want to ask a question, like, can we take like zero apples or zero number of like one of the product to be 0? Is it possible?
Oh, one of the product to be 0?
Yes, like point by 0 and 5.
as your coordinate, eh?
Yes.
Yes, it is possible.
Because in many cases we get, if you use that, then in many cases we get two values which are higher.
Okay, I think I'm going to talk about it. I don't know whether you're talking about the graph or you're talking about this. But I'm going to talk about it. I'm going to talk about it. So let us first continue now with this item. Now, when you look at this item, they're telling us that a school is preparing a trip for 400 students. The company that is providing the transportation has 10 buses of 50 seats each and 8 buses of 40 seats, but only has 9 drivers available. The rental cost for a large bus is this, 800, and for a small bus is this. Now, I told you to know what you are going to let, first read through the question here. Now, our question is telling us that calculate how many buses of each type should be used for the trip for the least possible cost. So here you are looking at minimizing the costs, but they're asking you for each type of the bus, meaning that when we are letting, I'm going to ask myself, when we are letting, I'm going to say that let, because it is the buses that are going to differ, I'm going to say let X represent maybe the smaller buses. But here, since we a school is paying a trip for fun, they come with it has 10 buses of 50 seats. Now this is the bus. So we have the big bus and then the small bus. So since we have started with the big bus, I can say let X represent, can I call it the big bus? Hope you can. Or let me say X represents the large bus. Sorry. So let X represent the large bus. And let Y represent the small bus. Now, after doing so, because they are the buses that are differing, I'm referring to the large bus, the one that is carrying the one of 50 seats, and the small bus, the one for the 40 seats. So here even I can specify that large bus is the one for the 50 seats. Small bus is the one for the 40 seats. Then after I draw simple table. After me knowing what is going to change, so what is changing is the 50-seat bus, 50-seat bus, and the 40-seat bus, or what I've called the large and what I've called the small. Now, after knowing so, I ask myself, the company that is providing has 10 buses or 50 seats and 40 seats. So I'm going to ask myself, the first question is going to be, what is the seating capacity? That this large bus takes 50 people. The small bus is taking how many people? That the small bus takes 40. Now that is the first thing you need to know. After knowing that, I'm going to ask myself, what is the availability of the drivers we have? That for the large bus and the small buses, the drivers, now here I'm looking at the drivers. Here, this seating capacity is going to give us the total number of children that these buses can take. So in total, since we have 400 children, this one will be 400, our total. Then when it comes to the drivers that are available are 9, meaning that the drivers that are going to drive the big bus and the drivers that are driving the small buses, when I get both of them, it should not be above 9. Then I ask myself, since the school is in need of minimizing the costs of transporting the children, mid-renting, now here I'm going to say cost minimization. For us to get the large bus, we need 800,000. To get the small bus, we shall need 600,000. That is the cost minimization. And that is what we call the function we are going to use to determine which two can we use? Now from here, after summarizing, we can be able to form our inequalities. So the first one I'm going to get is going to be the seating capacity. The capacity of seating. Now the seating capacity, it means that if this bus is X, it is representing the large bus. And the one, when I combine the large plus the small, the number of children to be transported should be 400. But the thing, a school is preparing a trip for 400 students. Now I want you to use the chart and you tell me, when you look at this statement, are we using greater than or equal to, or we are using less than or equal to? Use the chart to tell me, what are we going to use? When they say the trip is for 400 children, greater than or equal to, greater than or equal to 2. Greater than or equal to, greater than or equal to. Okay. Ruth, can you tell us why you say so? Yes, Ruth, your hand. Yes, Ruth?
So we say so for specifically transport and party purposes. If the question is based on transport or it is a party, we say so because we are not sure whether exactly 400 students will go. We can't be certain. So we either say that they are greater than, that the students will be more, or even the people will be more going, or actually equal to what? 400. That's how our teachers explained to us. I don't know if I've explained, I've satisfied it.
Okay, thank you. Thank you. That is correct. So here we shall come and say 50x plus the 40y should be greater than or equal to 400. Then the next inequality is going to be for the drivers. Now, when it comes to the drivers, we have the drivers that drive the X, the large bus, plus those that drive the small bus. They are telling us that the school has 9 drivers available. And we say that when that is the maximum number of drivers they have. And we said for maximum, we shall say less than or equal to 9. Then the next inequality we are going to write, we have the cost minimization because we are looking at minimizing the costs. So I will say cost, I put XY is going to be 800,000 X plus 600,000 of Y. Then I write the non-negative inequalities, X greater than or equal to 0 and Y greater than or equal to 0. And those are my inequalities. Yes. So, yes, Victor.
So I have a question. In your first inequality, you have 50x plus y is greater or equal to 400. How is that possible? Supposed to be all equal to 400 because there are 400 students that the school is planning to take.
Yes, okay, Victor, stay on. Now, when they are making preparations, you are not sure whether the 400 children will go because you are preparing something for 400. But there are chances that the number of children that are going to go can be more than that. So in preparations, like even it is always good when you are preparing something, do not prepare exactly that. You always have an extra, like when you prepare a party for 400 people, it doesn't mean that 400 people will come. It will mean that more than can come. So for you to be on a safer side, always it is better you prepare in advance for more people that can come or can appear to be safe. So don't prepare for the exact, but prepare for more. Even in preparation, when you are reading, you cannot say that I'm going to spot and read only this. No, always make sure that when you are prepared, you prepare for much. Alvan, terms, yes, okay.
My question is, why can't you also form this equation of x plus y is less than or equal to 18.
18. How are you getting 18?
From the total number of buses they should hire, they should be less than 18 buses, which the company has.
Oh, you are saying
I'm saying that can't you also form this equation of x plus 1 is less than or equal to 18.
Okay, now, what is going to bring, now for that particular one, when you say the company has 10 buses, so when they say has 10, remember that one, which inequality do you use? Oh, he has gone off. Okay, when they say has, it means you are going to use less than or equal to. When you say 8 buses, it means you should use, because that's what they have. So since you have two inequalities, we may not be in position to combine. However, the intention of the question is looking out for which type of the bus, not how many. They are looking out for which type of bus or which kind of combination can be used. So that's why we are sticking to only finding out, because in order for us to answer the question, what we need is the type that should be used for the trip. We are not looking at whether we are using all the 10 buses or we are using the 8 buses, but we are looking for which type. That is the intention of the question. Okay, I think let me first continue such that we can be able to do. I want us to do about 9 items. Okay, now we go to another one. You can place your questions in the chat. We can be able to attempt to them. Then another one is here. A transport company has 2 types of trucks, type A and type B. Type A has a refrigerated capacity of 20 meters cubed and a non-refrigerated capacity of this. In contrast, type B has the same overall volume with equally refrigerated and non-refrigerated stock sections. A grocer must hire trucks to transport of this and this. Now, here the first thing I want you always to pay attention. What are you going to let? So in order for you to find what you let, first read the question. What does the question want? Now this is our question. Now I want you to use the chat to tell me, what are we going to let? What are we letting for this particular question? Use the chat. Yes. Liz, the student may be less or more. Which one is better? More is better. More is better. Someone is saying the number of trucks. Number of trucks. Very good. So we are going to let the trucks. So we are going to say, since we have here, they want to find the trucks. So we shall say, and we have 2 types of trucks. So we shall say, let X represent type A truck. Let Y represent type B truck. Now I'm going to draw my table. In my table, since I've already let what I want, so I will have type A, I'm going to have type B. Now, after having those 2, I'm going to now read the question. Type A has a refrigerated capacity and a non-refrigerated. So I will say I have 2 things. I have what we call refrigerated and I have non-refrigerated capacity. So what is the volume? For refrigerated, type A has 20. Non-refrigerated, it is 40 capacity. Then I go, in contrast, type B has the same overall volume. Now here is where I want you to understand. Type B has the same overall volume, meaning that the overall volume is going to be 20 plus 40, which will give us 60. That is the overall volume. With equal refrigerated and non-refrigerated section. I want to see in the chat whether people have understood that statement. With equal refrigerated and non-refrigerated section. For type B members, I want to let me know what is the volume for refrigerated and for non-refrigerated. Type in the chat and we see whether people can. Type in the chat that part now. All 30, 30, 30, 30. Good. Very good. So since it is equal, we shall divide this by 2. So here I'll put 30. I'm going to put here 30. Then I will continue and I say, a grocer must hire trucks to transport 3,000 of refrigerated stock. What does it mean? It means that the available, the total for refrigerated is 30, is 3,000, the volume. For non-refrigerated, it is 40, is 4,000 of non-refrigerated. The cost per kilometer of type A is 30. Then here I'm going to say the cost. Type A is 30,000. Type B is 40,000. Now, after doing so, we are going, I'm seeing a hand. I'm seeing a hand. Yes, Frank. Frank? Okay. Frank's hand is down. Okay. Now, after that, I'm going to now to come and summarize. Now, they told you that here I want you to take note. Now, the available space that is available for the grocer to transport, a grocer must hire trucks to transport 3,000. It means that what the person is owning, what the person has is 3,000. The things he wants to transport have or occupy a volume of 3,000. And if that is the volume that is to be occupied for the refrigerated thing, type in the chat and let me know which inequality do we use. If that is the available volume that he wants to transport, which inequality do we use? Type in the chat and we see. Type in the chat and we see. I want to see whether people have understood that statement. That what he wants to transport, the volume is that less than or equal to, that is Ian. Thank you, Ian. I'm waiting. Less than or equal to, less than or equal to, less than. Okay. Okay. I want you to read the statement again. I want to repeat. They are telling us that a grocer must hire trucks to transport 3,000 of refrigerated stock and 40 of non-refrigerated stock. Yes. Greater than. Now I'm seeing two answers, but allow me to ask. I'm going to ask. There are people who are saying less than, others are saying greater than. Now, I want us here, this is where the reasoning is coming from. I want to hear people. Yes, Bridget.
Yes, sir.
Yes,
sir.
ask.
Do you please help me and repeat the overall where you've added 20 plus 40? I've not understood.
Okay, now you keep on. They are telling us that for A, the refrigerated part is 20. The volume is 20. And the non-refrigerated volume is 40. So what is the total number? 40 plus 20 is?
60.
60. So that is the overall volume for the things, for the refrigerated capacity, what the capacity can. So meaning that since they have told us that has the same overall volume with equal, so the part of refrigerated part for truck B takes 30 and the non-refrigerated also takes 30. So that's why we have, yes.
Thank you, teacher.
Okay. Now, looking in the, now I've seen people. Now I want people who have given us an answer of less than. What does it mean? When you say that the inequality is less than, because this person wants to transport 3,000. Take an example. Let me give you an example. When they talk about refrigerated things, those are the things that can get spoiled quickly. Let me say meat. I know meat, I think, gets bad. Let me say this is meat. Then non-refrigerated are those things that take a longer period. Let me say, which one can I? Let me say sugar. Now, when you say that the refrigerated part, it means the space that is available is 20 and 30. So when you say less than or equal to 3,000, it means that this person may transport the 3,000 he wants, or he may transport something less than that. That is the meaning, or 2,000. Now, if you say less than or equal to 3,000, it means that there are chances he can transport 2,000, but he has not hit his target of 3,000. So this inequality of less than or equal to cannot work. The reason being that what he wants to transport is 3,000. So for you, if you say that is less than or equal to, there are options that he can transport 3,000 or less than that. And we have said that when it comes to these things, always having something more is better than having something less. Because if you have something less, you may not be able to achieve your objective. But if you have something more, it means you'll be able to achieve your objective. Kindly let me know in the chat whether you have understood that point, why we are going to use greater than or equal to. Just say yes. We are on. Okay, I'm going to repeat for some who have not yet understood. I'm saying that the space that is available for refrigerated part is 20 and 30. But your objective as a business person, because you want to go and make profits in the business, and what is available or what you want to transport is 3,000. Take an it's 3,000. Meaning that if you say less than or equal to 3,000, here the possible chances are you can transport your 3,000 or something less than that. But you have not attained your objective that you want to transport 3,000. So in order for you to bring out the idea, you transporting more than 3,000 is better than you transporting something that is less than. That is the meaning. So you getting a mark, if you want to get 80 in a paper, you getting more than 80 is better than you getting less than 80. So that's why we want to use. So you spending time reading day and night and you get something less than 80 is counterproductive than someone who reads day and night and he gets above or equal to 80. Let me hope we have understood that. Okay. Now here, for the first inequality, for the refrigerated part, I will say 20x plus 30y must be greater than or equal to 3,000. Let me hope that is okay. I want to ask, let me sample. Victor, is that fine? Yes? What about Anna? Is that fine? Okay, let me hope that statement is okay. So the moment you use here less than or equal to, it means that you are going to transport things that are not going to help you achieve your objectives. That someone can say, you have transported 3,000, they can transport 2,000. And you know how those, let me even put it in the business sense. You know the business people. Now, if for you use less than 3,000, these people who cheat can easily cheat you. Because when you tell them, when you say less than 3,000, for them, they can even put for you something very small, as long as they have put for you what you want. But when you tell them greater than or equal, it means that they must attain that. Take an example, you know these trucks that carry sand. Some people, when they are buying, or for some companies, they say that sino truck, we want it when its weight is above this. But if for you tell them, I'm using a sino truck, I don't know that you need a sino truck. A sino truck is is those big trucks that carry sand, the red ones usually see. When you tell them that I want 3,000 tons, maybe I want 5 tons of sand. Now, for you, when you tell them, when you say it must be less than or equal to 5 tons, this person can even give you 1 ton. But when you tell them that you must be greater than or equal to 5 tons, this person, what he's going to do, he will give you either exactly the 5 tons or even he can put in on more. But if you tell them less than or equal to 5 tons, when they go to the factory to get the sand or to the areas where they're getting the sand, mining areas, they can put for you something less than. That's why even you have seen them, always when they reach a certain places, they keep on reducing the sand and they sell it off. Because for you told them, I want a Sino truck. So whether it is less, you don't mind. But if you tell them it must be full, then they have no way they can reduce. Then I go to the non-refrigerated part. Now, when I go to the non-refrigerated part, still I will do the same because this is what you want to transport. So I will say 40x plus 30y, 40x plus 30y must be greater than or equal to this available space, which is 4,000. Then I'm going to go to another inequality. So another inequality here I have that the non-negative one. The space should always be greater than 0 and our y must be greater than 0. Then I'm going to write now the cost because I want to minimize. So I will say now my cost of xy is going to be 30,000 x plus 40,000 y. So those are my inequalities that I'm going to write. Yes, kindly let me in the chat whether we're on the same page. Should we continue? Just say yes, 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 and we see. Oh, no. Yes, terms.
So, teacher, I wanted to supplement your explanation because when I passed the chats, I was saying some are still not getting it.
Okay, it is very okay. Please go on.
So, teacher, it's like when we use greater than is, in other words, we use like a mindset of business. An entrepreneur always looks for those ways of lowering the expenditure in order to maximize profit. So if they're transporting stuff from somewhere to other place, they'll try fixing they'll get, even if the capacity of the car is like 4 items, they'll fix stuff in the corner like that. They'll fix more stuff just to minimize the transport expenditures so that they maximize their profit. So the items will be more. Yes, teacher.
Okay. Yes, very good. I think that is a very brilliant idea. I think you have seen even, you know these tax people, in order for them to minimize on the fuel costs and for them to maximize the profits, always they'll fix you. The taxi takes 14 people. For you, they can even put how many? They can put 15, 16, like that. They are minimizing the fuel cost, but they are maximizing. So when you are transporting things, you ask yourself, what is your objective? Yes, Blessy?
Yes, teacher. On this other part where you said that the x is greater than or equal to 0 and the y is also greater than or equal to 0. How about when they say, because I remember at our school we had x is greater than or equal to y, and they would cross through on the graph. When does that happen?
Oh, we are going to look at a number of that nature, whereby they say x exceeds this, like that.
Oh, okay, sir.
Okay.
Thank you.
Daniela?
Good morning, Teacher Steven.
Good morning.
So I wanted to ask, can we end up with 3 equations in such a number? No. If they give us a number, for example, the number 4 above, and then somewhere you end up turning up with 3 equations, do you think that can happen?
Yes, you can have even 2. It is very possible.
Three.
But when you
Three
find yourself
questions.
having two, yes?
Three, like three. 1, 2, 3 equations.
Yes, you can have three. Even two.
Okay.
I have seen a mock, there is a mock I saw which had only two. But the other ones that could come could be the ones for non-negativity.
Okay. Whatever that one is.
Okay. Adrian?
Yes, thank you so much, sir. I for me just want to thank you for grateful lesson. You're just understanding things, entering very well. Yeah.
Okay. 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 Thank you. Thank you. Okay. Now let us continue to another number. Item number 6. I've said our intention is to derive those inequalities. And after this lesson, I'm going to give you to try out. Then, let me see what is the time. Okay. Let us first derive. Then I'm going to give you, and then we shall look at. Now, they're telling us that a school has organized a geography study tour for 90 students. 2 types of vehicles are needed, taxi and coaster buses. The maximum capacity of the taxi is 15 passengers, while that of the coaster bus is 30 passengers. The number of taxi will be greater than the number of coaster buses. Now, I told you always read through the whole question and come to the tasks. Ask yourself, what do the tasks want me to do? They are telling us that from your graph, you graph the number of taxi and coaster buses that can be ordered. So here, what is varying? They are looking at the coaster and then the taxi. Meaning that when we are letting, we are going to say that let X represent the number, the taxis. Then let Y represent the number of coaster buses. Now, that is the first thing you need always to do. Now, after that, you can still go on. For me, I love summarizing my work. I have the taxi here. I have the coaster. That is the first thing. Then you ask yourself, you are going to ask yourself, what is available? A school has organized a geography study tour for 90 students. The total number of students are 90. They are telling you that the maximum capacity of the taxi is 15 and this one. So you are going to look at the seating plan or the capacity, carrying capacity, that the taxi can carry 15%. Okay, sorry. Can carry 15 passengers. What about a coaster? A coaster carries how many? 30. But you ask yourself, what is the total number of students you want to transport? That I want to transport 90 students. Hope that reasoning is coming out. The taxi takes 15, coaster takes 30. But the total number of students that the school has is 90. But I want you to remind you, when it comes to transportation of the things, always when they say the school has 90, the school has a tour for 90 students, don't overthink. If that is the number the school is preparing for, then always better. You either prepare for exactly that number or for more than that number, but not something less than. So here the inequality we are going to use is going to be greater than or equal to. So I'm going to write my inequality for the capacity, seating capacity. So it is going to be 15x plus 30y is greater than or equal to 90. So when I add the x times the y, in case this one is taking one root and this one is taking one root, then I will be able to get. Then the next one, I'm going to come and I say that the number of taxis will be greater than the number of coaster buses. Now here you write the taxi, you said the taxis is greater than the coaster. Now you ask yourself, when they say greater than, so taxi is X, greater than is this sign, coaster is Y. So that is my second inequality. Then you continue. The number of taxi will be less than 5. So you say taxis will be less than 5. These are the taxes. So what will you do? You'll say taxi is X. Less than is this sign 5. That is the other inequality. Then you continue. Other inequalities are going to be the non-negativity. X is greater than or equal to 0. Y is greater than or equal to 0. Then after you ask yourself, what is the aim? The aim of this is to minimize the costs. Because whenever you are transporting, you want to minimize the cost. So I will come and I say now, what is going to be my cost? I will say my cost, X and Y. They told that the cost of hiring a taxi is 60,000. The one of hiring the other thing is 100 what? 100,000. But the school, there is only 600 available. So here I will put here 600 available. Now, in order, we are going to form another inequality now. The other inequality is going to be about the costs. In fact, here, let me first remove cost. Then I can add here cost minimization. Now, the costs is going to be, now that another inequality, we shall have the 60,000 of X plus the 100,000 of Y. Then, but they told that there is only shillings. Please, members, let me see whether you know in the chat which sign we are going to use. There is only 600,000. Which inequality do we use? Type in the chat quickly and we see. There is only less than or equal to. Thank you, Shadrach. Yes, less than or equal to. Even Chilabo, good. So I will say less than or equal to 600,000. That is the other inequality. So I have 1, 2, 3, 4, 5, 6. Then the seventh one is the cost, because you are looking at minimizing the cost. So you form your objective function. And here, since in order for you to determine how you are going to minimize, it will depend on how many taxis and how many costers. And the cost of hiring is 60,000. And the cost of hiring this is 100,000. So I'll come here and I say, my cost is going to be 60,000 X plus 100,000 Y. So that is my objective function. Kindly let me know in the chat whether we are together. Why do you say less than or equal to? Hannah, we say so because that is the amount you have. It can't be beyond that. If in your pocket you have 600,000 or 10,000 for your pocket money, if your parent gives you only 10,000, you can never have anything beyond that. So it is always less than or equal to that. Okay. Okay, I think we're okay. I'm seeing Blessing, you have a hand, and Ruth. Yes, please.
Teacher, for me, my question is, I'm still arguing on these non-negative equations, because what if your scenario has a negative? Probably, maybe we have this part of X is less than maybe -5. The scenario has a negative. And then for you, you use X is greater than 0. For some reason, you're going to shed the opposite side, the unwanted region, and you're going to have to shed that space that could have been part of the what? Okay, that you would shed part of the space that could probably give you your maximum profit, or yes, especially maximum profit, which is at the corners up. I don't know whether you're getting my complaint.
Yes, I am getting it now. Ruth, let me, okay, that one can be possible, but that is advanced linear programming where you use the simplex methods and the rest of that. At your level, Ruth, you'll never get a negative. Take it. You'll never get a negative. And always, in fact, I'm going to show you when we reach the graph work, you'll never have a negative unless there's an error in the question, but it can never be negative. You will never use a negative space. 2, like I've said, that whenever you are entering into something, you are entering into business, the use of linear programming is to maximize and minimize. Those are your intentions of doing so. for anything you are doing, you are either looking at minimizing the costs or maximizing the profits. So if those are your intentions, you cannot have it. For any business you are entering, you want to get profit. So you cannot say, I want to get negatives. So you getting negatives, it means you are getting losses. And that's not the objectives of the linear programming. So the intention is to maximize and minimize costs. Maximize the profits, minimize the costs. So Ruth, you'll never, and even when you meet such a, you can never and never, and you'll not. So for you, in fact, I'm going to talk about it. When you go to the paper, I'm going to show you the first marks you are going to get. But let me first finish these scenarios. I will show you on the graph. There are those 5 marks you can get even before doing anything.
Okay, please. Thank you.
Okay, but always include those 2. Hannah or Ramadan?
Yes, sir. I need you to clear me on something. Are you going to add the cost, like the cost, the cost
You are not.
equation on your graph?
No, this cost equation, this one. Yes, this one of 60,000, 100,000, and 600,000. This one, you will add it. It will be on the graph. But this one, for the cost, this one, it is just to help you to find out how much you are going to spend.
Okay.
Hannah?
I'm just kidding. I mean, 5 is greater than 0 and 4 is greater than 0. Are we also supposed to write x with 0 even y is greater than?
Yes? Now, these inequalities of less than 0 is to show that the taxes can never be negative. The costas can never be negative. That's why you include them. You can have a combination where you have only costas and no taxes. That one is possible. But you can never have them as negative, that they can never exist. In fact, you having a negative, it shows something that does not exist in these linear programming problems. Okay, Viola?
Okay, thank you very much. My concern is on the inequality for the capacity. We have the capacity of the taxi is 15, then that one of the costa bus is 30. And the school has organized the study tour for 90 students. Now here you've said 15 plus 30y is greater than or equals to 90. According to me, the students organized for the tour, they are not greater than 90. They don't exceed 90. According to my understanding, the inequality
Yes, Viola, go on.
90 because the students are not above.
Is equal to? Now, Viola, one thing you need to know is that here, remember when we say greater than or equal to 90, here you have factored in the equal one, that it can either be 90 or more than that. So here, since we are dealing with inequalities, linear programming, we deal with inequalities. So we don't use that equals in inequality. Only we use it when we are plotting. So that what caters for it is this greater than or equal to. So you equals to 90, it is being catered for that. But remember when you are preparing, even when you are preparing for your functions, Viola, if they tell you, if you are preparing for 90 people, you can never be accurate. You say if they are 90, what if more than that one come? What if more than come? So that's why we say greater than or equal to. You must always be prepared for the possibilities, other than preparing for the impossibility of having less than. So that's why we are saying greater than or equal to. The 90, since the school is preparing for 90, the 90 are catered for. But even in case there are other children who may be added on the last minute, they can also be catered for. So it is always better to prepare for advance than preparing for something below. Are you getting it?
Yes.
Okay. And always here, never use equal sign. Always use inequalities. Less than, greater than, or equal to, or this. Okay.
Okay.
Akram and Joan, I'm displaying another question, people to be reading through.
Good morning.
Good morning.
Yes. Good morning.
My question was, the part B in the question is asking us for which number of taxis and number of costas we should be using, but why is the objective function a cost function, and yet they're not.
What
is your objective function a cost function, like it has money instead of the number of taxis and things, yet they didn't ask us for the maximum cost or profit or something like that.
Oh, now, why do we have the money? One, the reason is that for you to determine, for you to determine, like when you are transporting, you always want to have, let me say, you want to use less money. So for you to be able to find out the less money, for you to be able to get to know how to know, you need to know which options or which combination is going to be using this money. So you cannot, in order for you to know it, it means you need to know to use the cost matrix, the cost equation, to know which combination is going to be giving you the less money. I don't know that you're getting it.
Oh, I've got it. Thank you.
Yeah. So your basis should be which option is giving me less money. That when I use this and this, which one will give me less money? Okay. Let's be reading through that question. Let's be reading through that item. As I pick Faizo, or wait, I plug in. Faizo, Joan, Sandy, you can unmute.
Oh, teacher, thank you so much for the lesson.
Okay.
Yeah, but you have answered my question as you were answering Joan because it was the same.
Oh, okay.
I was also having the same question.
Okay. Sandy? Queen Elizabeth? Sandy?
So for me, my question, the part that you are getting the cost instead of the number of people on part B.
Oh, okay. Now, okay, Queen, we have not completed the question, eh? Now, members, please remember, we are not doing any question, eh? Queen, I'm just showing you how to come up with the inequalities. Then we are going to reach time where we are going to solve and come up with the solutions. Is that fine?
Yes, but as you can, is it that when you like you're finding the maximum thing, like the inequality that we are going to use to find the maximum or minimum, was showing us costs, not.
Okay, I think Oh, okay, I get what you are saying, eh? Now, that is very okay. Okay, I've seen the question wanted us to obtain from your graph, determine the number and question buses which are full to capacity that must be ordered. Eh? Okay, that is very okay. That is very okay. I think I did not read it very well. So if that is to the full capacity, then if at all you are maximizing, now like this part, if you are maximizing to full capacity, if it is the question, now there are two things. The question, there are some questions you are going to meet that you require to find where you are minimizing and at the same time maximizing. If you find such a question, then it's okay, use this. But if you find a question when it is typically asking you to find a maximum without you mining about the costs, then that one for capacity, you use this one. You say 15x plus 30y. So that is the one that you can use. Hope that is okay. So if the question now, like part B, if it requires you to just find, because they say from the number of taxis and which are to full capacity. So to full capacity, this is the equation you use to find it. If it is for cost, let me add part C. If it is for cost, for minimizing the costs, then it is this. Yeah. But now this one being an open question, you can even do both. Find out that. But we shall do these questions. We shall do them. Okay. Allow me to go to the other part. Now, item number 7. I think this is going to be our second last. Oh, I have others. Oh, okay. Let us do more 2, and then we end at that point. Now here, they are telling us, okay, let me first mute. I think people have read through. They are telling us that your friends has who rears cows and goats during the festive season. They want to sell at most. Kindly mark those keywords, at most. But still, for me, I will first read through the question and I get to know what am I going to rate. They want you to help your friend to determine the maximum amount of money they will possibly make from the sale of cows and goats. So the question is looking at cows and goats. So when we are rating here, you'll say, let X. Now, always, like I've told you, what they start with is what you can use. So let X represent the number of cows. Let Y represent the number of goats. Now, after doing so, you come and ask yourself, you can summarize them in your table, or you may, but it depends. There are some questions where you can summarize, there are some questions where you may not. But still, you can come and say, these are cows and these are goats. Which information do I have? They are telling you that during the first, they want to sell at most 10 of their cows and at least 8 of their goats. Now, this is where I'm saying, whenever you find a conjunction, please be very careful. Those are two statements having two different inequalities, meaning that you can separate them. So I can say at most 10 of the cows. So at most 10 of the cows, meaning I'll say X at most, meaning that is the maximum. They don't want to go beyond that. At most 10, it means when you say at most 90, it means that for you don't want to go beyond 90. When you get 90, God has made your day. So you say at most 10. Then, and at least 8 of their goats. So I will say at least 8 of the goats. So that one for at least, we shall say Y is greater than or equal to 8. Then you continue. They want to ensure that the number of goats they sell, they also want to ensure that the number of goats they sell are less than twice the number of cows. Now, for this statement here, where you find twice, first write it. They say number of goats is less than twice number of cows. So what does it mean? Number of goats, we are using goats as Y. They are telling you less than. You put your less than. Twice means like 2 number of cows. That is your equation. Then they also don't want to sell more than 20 animals altogether, meaning that altogether, here the total, when they get the cows and the goats, the number of cows should not be more than 20. So when you find the word not more than, which inequality do we use, members? Which inequalities do we use? Less than or equal to. Less than or equal to. Not more than, meaning that the maximum is 20 animals. So meaning we shall say X plus Y is less than or equal to 20. Then after we have reached there, then they are saying they wish to maximize sales by selling each goat at 200,000 and each. So here you have in your table sales. for the cow is 1.5. So for you, don't write 1.5 million. For you, write it 1.5 million. Then here, they want it at 200,000. So this is the sales, or this is the maximization. So I'll come here and I say, now my sales XY are going to be 1500X plus 200,000 Y, which is for the goats. But they don't know the number of goats and the cows to sell to fulfill their wish. Then I'll add on the two inequalities. X must be greater than 0. Y must be greater than or equal to 0. Reason being, you cannot have negative animals. Animals can never be negative. So that's why I was saying you cannot have negative. So those are the inequalities for this particular number. Hope we're on the same page. Kindly let me know in the chat. Are we on the same page? Oh, are we on the Viola? What's not appearing? Okay, we're on the same page. We're on the same page. Yes, Hannah.
If we have x is greater than 0, and here I've seen y is greater than 8, and we're having the other inequalities, x is greater than 0, y is greater than 0, are you also supposed to plot 8 is greater than 0?
8, we don't have 8 greater than 0.
Y is greater than 8 or equal to
Y
8.
is greater than or equal to 8, yes. All these inequalities we are deriving. Hannah, we have to plot them. Yes.
Okay.
We are supposed to graph them. Okay. Yes, Kalema.
Good morning, sir.
Morning.
Yeah. X and Y will X less or equal to 10, those will be the solid lines.
Yes.
Okay.
Whenever there is unequal, it is the solid line. Whenever there is unequal, it is a solid line. Without a solid, then it is not. Yeah. Okay. Yes, Akram.
Teacher, about the number of goats less than twice the number of cows. Shouldn't it be like y is less than 20 to 10 to 20?
20?
Yeah.
Where are you getting that 20?
They said twice number of cows, and the cows are 10.
No, remember, you are not sure of the number of cows. Akram, unmute. You are not sure of the number of cows because the number of cows, they told you they are at most 10. And at most 10 meaning that they can be 10, 2, 3, 4, 1, or none. So you cannot commit yourself that it is 20.
Okay.
Is that fine?
Fine.
Okay. Adrian? So this is yours. I want you to be trying out for me this number. Everyone first try out on your own as I answer some questions. Yes, Adrian, and after you can type your inequalities in the chat. Adrian? Adrian? Okay. Kaima?
Sir.
Yes.
Thank you, sir. I'm asking that, is it necessary to do that table? That
No, it's
summary
not
table?
necessary. It's not necessary. But
Okay, thank you,
I
sir.
advise for you to draw in order for you to know, not to confuse the components.
Yeah. Thank you.
Okay, okay. So we are trying out that number. Everyone is trying. And then I'm going to look through the chat. After type your answers, I want to see whether we are somewhere. Yes, Sandy?
Teacher, please enlarge the questions.
Oh, what are you using? Phone?
Yeah,
Oh,
phone.
okay. I think you can place your phone there's a mode you can place your phone, but let me see whether I can. Let me see what I can, because I thought they are a bit big. Let me try and see. Hope you can be able to see.
Yeah, it's better.
Okay, JB and Elijah.
Yes, Teacher Kasumba. I was kind of requesting to ask if they can examine more than 3 varying constraints. For example, they can ask about, okay, in relation to this question, they can ask about dresses, they put in trousers and they put in shirts. Is it possible where they can use 3 more than two comparable things, 2 comparable objects, and they question them, or they have to only ask?
No, now, what you are going to know is that at your level, you cannot have more than 2 variables being asked. You cannot, but they can put very many statements. They can put very many statements, That's why I'm saying always have that table to summarize. When you have that table, it can give you a good summary. I think we shall do that question tomorrow. There is a question I think we shall do tomorrow about it, whereby they have put charts, they have put this, they have put this, but that one can be simplified using the table, knowing what, but what is important is you identifying which variables to use, to which ones to rate. That's where the problem usually comes from. I think there is a paper, I don't want to mention here mock paper, but there is a mock paper. It was, I think, a mock paper. It was a pre-mock where they mixed a lot of those things. But it was just in the matter of rating.
Thank you so much.
Now I'm going, okay. Yeah, but here at your level, expect just 2 variables. But when you advance in linear programming, in fact, when you advance, you learn about the real programming. Those people who are doing programming in ICT related activities, these programs can be solved. Many of the problems we have now, take an example, traffic. Traffic can be solved using these inequalities. Okay, I've seen people have sent in their answers in the chat. Okay, let me now also start. JB, do you have something?
Yes, good morning, Mr. Kaziba.
Yes, good morning.
I borrowed my question from classwork we did at school. So we were given an item. And in this item, X represented beer and Y represented soda. So I would like to just read one part of it, and I would like you to explain how this inequality came. It was at a graduation party. The guests are to be served with beer and soda, at least twice as many crates of beer as crates of soda are needed.
Okay.
So I'm wondering how this.
Okay, I have a question of that nature, I think. We are going to do it at the end.
Okay.
You type it in the chat. I'm going to pick it from the chat.
All right, thank you.
Okay. Okay, now here we have said that always first read the question. When you look at this question, when you read the question, you need to check out what does the question want, such that you know what to let. Now, to know what you want to let. So I'm going to come and ask myself, the question has in one dress is this, and a profit on a shirt. So here meaning that what we are going to let a shirt and a dress. So I'm going to say that maybe let X. Oh, sorry. So I will say okay, let me pick my pen. I'm going to say let X represent the dress. Let Y represent the shirt. So you write it in words, very good. Now, those who have summarized, it is very okay. But now I am reading. The tailor asserts after receiving the first stated how to improve. In 1 week, he makes at least 4 dresses. So you say at least 4 dresses. So we say the word at least means that is the minimum. That person can be making 10 or 15 or more than that. So I will say dresses, I will say X is greater than or equal to 4. Then I continue, comma, not more than 7 shirts. Not more than 7 shirts. Then I say for the shirts, not more than 7. So I say Y is less than or equal to 7 because we said not more than. The moment you see the word not, meaning that there is an equal on it. And less than 14 dresses and shirts altogether. What does it mean? Now, this is one statement. Less than 14 dresses and shirts altogether. Meaning that when they combine the number of dresses and the shirts made, all of them are less than 14. So I will say X plus Y is less than 14. The number of shirts he makes. Now, I've told for such a statement where you see 2/3, what? Write it. Number of shirts he makes is more than 2/3. Now, here you need to know 2/3 means what? 2 out of the 3 parts, the dresses. So I say shirts is Y. More than, I say more than, we said is greater than 2/3 of the dress. So I say 2/3 of X. Then after that, I'm going to write my X is greater than or equal to 0. Y is greater than or equal to 0. Now, here do not cram that under your mathematical statement or algebraic statements, you are going to include the cost matrix and the rest. Why? Because part 1 comes from the stem. So do not write it there because here in the question, you don't have anything. Then I will come, I do Roman 2, this is Roman 2, then Roman 3. The profit he makes on one dress is this. So this statement here, it will be marked from here, from part B. So you answer it on part B. That to obtain the profit here, you show us clear that profit XY is going to be 10,000 of X plus the 6,000 of Y. But on part B, when you're answering part B, you write it somewhere and then you continue with the calculations. So I'm happy that I saw some of those answers in the chat, and please do not forget to let. Okay, I'm seeing. Yes, okay. Those inequalities are good. Thank you. Can't you? Yes, now yes, for the last one is okay. For the fraction, some of you can simplify. Those who want to write 3y greater than 2x, that one is also okay. It is fine, no problem. Yeah, there is no problem. But always better you leave it the way you have interpreted it or the way it was given in the question. Yes, JB. Now you are going also to try for me this one, this other question. Everyone, first try on your own. We are trying on our own before I come in. Yes, JB. Okay. So let me hope there's a person I try to answer. Okay. We are also trying this one. Yes. Let me hope, Adrian, you are understanding. I'm seeing Tracy, Alex. Alex, are we together? Are you understanding? Okay. Darius, Frank. Let me hope we are okay. Ivy. Joseph. Joyce,
Yes, teacher.
are you understanding?
Yes.
Okay. So, Susan, are you picking? What one, Susan? Okay, so everyone is trying. Okay, yes, Joan. Yes, Joan.
So I'm having a hard time choosing which one is X and Y because in the first statement, okay, you say the first thing they mention is X, and the second thing they mention is Y. So in the first sentence, they say that two classes are executive and ordinary. And then in the second statement, it says there must be at least twice as many ordinary seats as executive seats. Do we still remain
Okay,
with
now
executive?
in the opening statements, what did they start with?
Executive.
So that is your
X.
X. Continue.
Okay, that was my question. Thank you.
Okay. Okay. Okay, I'm saying some answers are coming in. I'm saying the answers are coming in. Okay. Yes, Sandy and Josh.
Teacher, I had a question on item
Yes.
7. Could you just take it a little bit back and I ask?
I go back.
Hello.
Okay.
Yeah.
Let us first wait for Sandy. Yes, Sandy.
Okay. Item 7.
I go back again to another question.
To item 7.
Okay, item 7. Yes.
Okay, my question was, was it very
So I was asking you turn back to
Wait
the
a minute.
question.
Okay, first wait for her to ask, then you come in. Yes, Sandy, continue. Sandy, go on.
I think I am not seeing the question. Do you
Yes. You are not?
I'm confused already.
From where?
it was this question that that they had put 15x plus 30y was
It had? It had?
okay, let's go on.
Okay. Okay. Now, okay, let me not promise inbox. I may take long to respond, but maybe I'll answer it at the end. Now, I have told you like always the first one should be the guiding principle. So they are telling us the manager of the hall wishes to divide the seats available into two classes, executive and ordinary. So here we shall say, let your executive be your X, let the ordinary be your Y. Now you start interpreting. So what have they told you? But here please let the number of executive seats be X. Let the number of ordinary seats be Y. Then they are telling there are not more than 120 seats available. What does it mean? It means that when you get the executive and the ordinary seats, they are not more than. And we said not more. Not means there is unequal. So I will say X plus Y is less than or equal to 120. Then they went on. There must be at least twice as many ordinary seats as their executive seats. Here is where now we are going to bring. So they're telling us that there must be at least twice as many ordinary seats. So what does it mean? It means that the ordinary seats, there's a person who was asking about the graduation. I think we can use this. It means that the ordinary seats are at least twice. At least what? Twice as executive seats. That is the meaning. At least twice as many ordinary seats. So meaning that the ordinary seats are twice as many as the executive seats. So looking in the chart, I didn't look. Okay, I think, yes. So, okay. Now, this one, it means that the ordinary seats, so we have let our ordinary seats to be what? Y. So it can be Y at least greater than or equal to 2x. Alternatively, people who have written this, it is also okay. People who have said 2x is less than or equal to Y. That one is also okay. Because you have said at least twice as many ordinary seats as. So if you have any of those two are really very, very fine. I want to repeat, the person who is asking, can I let A and B, please do not, then, okay, Victoria, you'll come in, and then they are telling us the ordinary seats are priced, executive seats are priced at 15,000 each. Ordinary seats are priced at least shillings should be collected at each show to meet the expenses. So what does it mean? Now that is the cost. So those who have summarized the table, I expect you to have this plus this greater than or equal to 1 million. Then our last one is the last one is going to be the profit. So in order for us to obtain the profit, so I will say the profit because the question wants to profit maximization. I will say XY will equal to 15,000 X plus 10, I think, 1,000 Y. And therefore, those will be your inequalities for that particular number. I don't know whether we are fine. I don't know whether that is okay. Yes, my Tina, I'm saying you can't mix A and B because plotting will give you hard time. you may fail to relate X and Y. You may fail to relate X and Y. You may fail to relate those two things, that A is my X, B is my Y. Okay, I think oh, okay. Okay, please don't forget to include X greater than or equal to 0, Y greater than or equal to 0. Yes, and I want you to always make sure you pay attention to those statements. Now, like that statement, there must be at least twice. That one, there must be at least twice as many ordinary seats, executive seats. Yes, that one, you must pay attention to it. You must pay attention to it very well. Otherwise, you will find yourself failing to do it. Maybe let me throw more light on that one. It seems some people are getting some challenges. Now, what does it mean? I know some people may get. They're telling you that there must be at least twice as many ordinary. So here, what do we have? I have my ordinary seats. I want to put it in a ratio form. This is ordinary to executive. Hope this is okay. Now, what does it mean? They are telling you that ordinary seats must be twice to executive 1. Meaning that ordinary, if ordinary, in case these ones are maybe 4, these ones can be 2. In case this is 8, this one can be 4. I don't know whether you are getting it. First, let me know whether you have understood this statement. That the ordinary seats to executive seats, the ordinary are 2 compared to the executive seats. Is that statement okay in ratio form? Kindly just say yes or no. Is it okay? I want to know whether people have understood that. Not yet. No. Yes. Yes. No. Okay. Is where I want to start. No. No. Okay, I repeat. They are telling you that there must be at least twice as many ordinary seats. Twice as many ordinary seats. Meaning that the ordinary seats are twice. That's why I'm having, like the ratio for ordinary, I have 2. As there are executive seats, meaning that executive seats is maybe 1. Meaning that always the ordinary, remember, let us put it in real life. When I'm organizing a party, it means that my one ordinary person can pay, let me say, 40,000. If an ordinary person is paying 40, an executive person, executive is the VIP, can't pay 40,000. It means that an executive, a VIP, is going to pay more than. So a VIP will pay 80,000. That is the meaning. If an ordinary person is paying 10,000, it means that the VIP is going to pay 20,000. That is the meaning. That always the ordinary person, pays something less than the executive. So in ratio, when I'm putting it in ratio, this is the meaning, that the ordinary is twice as the executive. I hope I'm getting it. That one you are obtaining. Now we are putting it in a local setting or in a format that an executive one always you pay higher than an ordinary one. Now, when I put it in this scenario that I have, let me erase some things here such that I'm going to write here down. Now, oh, sorry. Okay, let me write here. I have space here. Now, I've said that this is ordinary to the executive person. So they have told us that the ordinary person is twice as the executive. So mathematically, it means that our ordinary person according to our question, we are calling the ordinary person Y, and we are calling the executive person, we are calling this executive person to be our X, should equal to 2 to 1. So when you convert this into fraction, it will be Y out of X is the same as 2 out of 1. But since they use the word at least, so at least means greater than or equal to. So here I'm going to say my Y is equal to, when I cross multiply, it means it will be 2x. Is that fine? So what does it mean? This one means that this Y is paying twice as X. I don't know whether you get. So since we have our, since, I don't know whether it is clear. So that is the interpretation. Then you are going to bring in you are going to bring in the inequality things of at least. So I want us, okay. So please pay attention to that one, at least twice. So an ordinary person and an executive person. So you need to reason out such that you bring the idea very well. So that's why for my inequalities, you noticed, I think, I don't know where it is. You noticed that I had 2x. That's where it came from. Okay, people now have it there. Now, those are some of the inequalities I'll have. So when they say at least, please pay attention to it. Those words at times they confuse you a lot, and you find. But one way to mark yourself, if you find such numbers, you can do it and you graph it. But where are you going to find it? You are going to find yourself that once you make a mistake on one inequality, once you shade, you'll find yourself shading everything. So that's where you need to go back and you realize that there is a mistake that I made, and therefore I have to repeat. In case you make any mistake on one of the inequalities, you'll find yourself that yes. So that one, it means that the number of ordinary seats must be many. So that is the meaning. So the number of ordinary seats must be many compared to the number of executive seats. Okay, hope that one is okay. Yes, so when you are making a party or when you are preparing something, you cannot have the number always less than. So please, that is the meaning. Hope this is very fine. Please pay attention. Y represents the ordinary seats. Y represents our ordinary seats. So since they used at least, that's why we came here and just put the word greater than or equal. So it becomes Y greater than equal to 2x. So Y is the ordinary seats, X is the executive. So for ordinary, in case executive, you have 5 seats. For ordinary, you can't have 5, have more. Say that is why we say 2 times 5, which will give us 10. Hope you have understood. Kindly let me know in the chat whether that one is very clear now. Just say in the chat, yes, it is clear now. Okay. Yes, I don't know whether, Ruth, did you notice the mistake? Ruth, let me know whether it is clear. I saw one of your inequalities.
Teacher, it's not very clear, but I think I'll go with the ratio. The explanation is still not clear, but the whole ratio working will do it.
Okay, Ruth, are you first at me? Have you understood the ordinary and the executive? Have you understood that part in real life?
Yes, when you use the example of 40,000 and 80,000, but when you came this side and this very white board, I did not understand how, again, the ordinary are greater than the executive.
Oh, okay. I come because they said at least. At least means that like the chairs. Like let me use 40,000. Okay, we have said ordinary are paying how much? 40,000. Not so?
Yes.
Then the other ones are paying how much? 80,000. So if the ordinary, this is Y is the ordinary which is paying that. It means that I will say Y is equal to twice times this one, X is the our thing. It will be 80,000. So meaning that the ordinary is going to be, the total amount of correction is going to be like 160,000. But allow me to use the chairs. Let me use chairs. That if I'm preparing a function and I'm going to prepare a function for ordinary people, or you have seen these concepts people prepare, they always have executive or VIP, and they have for ordinary people. Ordinary people, you'll find them putting very many chairs, very many. And for VIP, they always put few. Now, if for VIP Ruth, you have put for a VIP person, you have put for them 4 chairs, you are not going to put 2 chairs for ordinary. Because if 4 people have confirmed that we are VIPs, we are coming, you cannot put the same chairs for the ordinary. So for the ordinary, the number is going to be more than that. That's why we have this greater than or equal to. I don't know that you're getting it.
Yes, it makes more sense now. Thank you.
So you will say now ordinary will be 2 times the 4 for executive, which will be 8. So you prepare more for ordinary. That's why even, let me not use. Okay. Even like when you go to church, you'll find that for the pastors, for those people who lead in church, they put for them few chairs. But for you, the ordinary people, they put for you very many. Yes, Victoria.
Jamia was saying that at the end of the lesson, I want to give a closing prayer.
Okay, Victoria, you will do so. Okay. We are concluding Ramadan. Ramadan.
Yes, sir.
Yes, please.
When do you use this approach most times?
When you find those statements of at least this,
Okay.
Yeah, I don't know whether the person who asked JB, you asked about crates, you can approach crates using the same. When they say at least as many crates of beer as crates of soda, I don't know whether JB you have understood now how you are going to approach it. JB, let me know.
Yes, please, I've understood.
So that's where you got that twice something. Okay. Yes, that is the concept of ratios and proportions. That is, when do we have ratios? Mainly we have ratios when you find those words of at least twice as this. So when you find them, interpret it. And always I want you to relate it to real life. Relate these things to real life. All the questions you're going to be finding in math, they are going to have real life. When you try to visualize it, you are going to be able to see that real life application somewhere. Or you must have interacted with it or found it somewhere. So, yes, Angel, you are the last one. Angel?
Hello. Good morning, sir.
Yes, good morning.
First of all, I want to thank you for sacrificing your time. And my question is, for example, when it comes to making the inequalities, for example, I make a mistake, and I make greater than supposed to be less than, but when I come on the graph, remember there will still be correct, and here I made a mistake. Will they mark me? Will they give me the marks?
When instead of using greater than and
when
use
for example, my inequality, for example, that is wrong, but here at the graph, after coming up with my points, But when I come on the graph and I do it very well, but here on the points when I'm writing the symbols, they are wrong. Like I did a mistake and I made them wrong. Will they still give me the marks?
They will give you for the graph, eh? They will give you for the graph. However, avoid when you notice that maybe your graph is not coming, you can go back and adjust, eh? You can go back and adjust, but they'll award you for the graph.
Okay, thank you, sir.
But avoid that mistake, because when you are operating in science, if at all I'm the one marking, I may not give you. A reason being is that just imagine you have made a mistake, you are maybe operating a person, you have made a mistake. There are some things you cannot proceed to get the right things. And I usually say that you can't get a correct answer from a wrong approach. So there you are going to miss out the coherence, the flow. So avoid that or try your best. When you notice, you can go back and change. Yes, Rory.
Good morning.
Morning.
Like my question is, where do we choose the points, like on the feasible region? Is it on the line or the feasible region inside there?
Or I said that one will always come on the corner points, the corner points of your graph. That region that you have remained with that is unshaded, you check out on the corners, Now those corners you have chosen is where the thing is. Given that those boundary lines are not dotted lines. Are you getting it? Yeah, if they are not dotted lines, always the maximum and the minimum are obtained from those sharp points. Like the way you see in physics, when we say that charge concentrates at those sharp points. Still here in math, your maximum or minimum always is at the corner points. Okay. Liz and Angel or Daniela?
Master, me, I was asking, like, sorry, are we going to have another lesson, like when you're teaching us about how to come up with the points that we are going to put on the graph?
Yes, that one is going to happen tomorrow. It's what we are going to do tomorrow.
Okay.
Okay. Liz?
Good morning, teacher.
Morning.
Like, I didn't understand somehow how the ratios came up.
Oh, okay. Liz, the ratios came up from this statement where they say that there must be at least twice as many ordinary seats as their executive seats. That's why we came up with the ratios. They, like here, they have two things they are comparing to. They are comparing ordinary to executive. So they are saying that, are you getting this? So they are comparing ordinary and executive. And they're saying that there must be at least twice as many. They are saying that the ordinary seats must be many. They must be many compared to the executive. So in case it comes to ordinary, in case the ordinary is 2, ordinary, they must be more than the executive. In case the ordinary, they are 4, it means that the executive, in case the, okay, this one should be 2. In case the executive are 8 seats, then it means that here should be more than that. That is the meaning. So that's why we came up with the ratios. And we said that since our ordinary, we had related ordinary to be Y, then executive was X. So since ordinary are more than the executive, that's why we said twice to 1 or 2 to 1. So when you work out your ratios, this is the same as Y out of X is equal to 2 out of 1, which will give you Y out of X is equal to 2 out of 1. But here equals is where we have at least. So that's why I'm putting greater than or equal to. So this will be greater than or equal to. So when you cross multiply, that's how we got Y is greater than or equal to 2x. Let me hope I have tried to hope. Then lastly, chamber of chambers. Daniela, I don't know, was it Daniela, the person who asked?
Yes, no, it's Daniela now.
Okay, yes, Daniela.
My question is that how are you going to help us to find okay, when we finish getting the points, maybe we put them in the table, then you help us to find how we get the wanted and unwanted. That's my question, and that's where I find a challenge.
Okay, yes, that one is what we are going to do tomorrow in tomorrow's session. It's the only things we shall look at.
Okay, thank you.
Okay. Nish and Sham.
Thank you, sir, for the lesson. Now, I was requesting for the timetable so that we can get prepared earlier for the lessons.
Oh, okay. I'm going to share, but just know, a math always starts at 5 a.m. every day for these 2 weeks, for 2 consecutive weeks. The whole of this week and next week, it will be from 5 up to around 8. Okay. I think, yes. And every day we have lessons happening at 8. At 2 p.m. For you, just log in the same room. You'll find them. Okay. I think let's end at this point. Now, what I want you to know, I want tomorrow when we come, I'm going to send this PowerPoint in your class for you to try out. Tomorrow when we come, we shall look at 3 scenarios, God willing, and those scenarios, we shall generate the inequalities. We shall go on and do the plotting. I will show you something on the graph. Yes, that's what we shall do tomorrow. Yes, but here I've included some scenarios that I want you to try out. There is one here, there is another one here, there is this one. So we have not finished all. So I want you to try them out. Then when we come tomorrow, we shall be able to try out all those scenarios. Then I'm going to share it and I will share the recording, I think at around 9. The recording will be there. Okay, lastly, 11. Oh, 11. I think I'm not hearing you well. Okay. Victoria.
Good morning, sir.
Good morning.
Maximization that we can.
Yes. 11, what are you saying?
Sir, could you please take us through maximization and minimization before you leave?
Oh, no, that's what I'm saying. I want to do it tomorrow. How to maximize and minimize tomorrow. That is a full lesson that we shall do tomorrow. It will require about 3 hours. But I think people are really tired because we came in at 5 a.m. Hope 11 you have understood. So we shall do it tomorrow. That one we shall dedicate the whole time tomorrow for graphing, looking for the maximization and calculating anything tomorrow. Yes. Sunday early, any problem? Okay.
Teacher, are we going to be doing linear programming for these past 2 weeks, or we're also
Okay,
going
sir.
to be tackling items?
No, now I think Sunday, every time we come, we do something. Linear program, because it is a bit lengthy, that's why we are going to do it today and tomorrow. After tomorrow, we shall not do linear programming. We are going to start another topic. Like last time we came, we talked about set theory. So we finished set theory. Yesterday, we talked about statistics. We finished statistics. So linear programming, we are going to do it today and tomorrow. After that, after finishing it, we shall look at another scenario-based questions.
Okay.
Okay. Okay. Victoria, lead us in our closing prayer.
Okay, sir. Thank you, teacher, for the lesson. We humble ourselves for prayer. Lord Father, we thank you for this day. We thank you for giving us the energy and strength to attend to these lessons. We pray that you bless our teachers, add them energy and strength to always come and teach us. We also pray for our parents who always provide for us. You may help them to always be there for us. We also pray for our coming exams. In Jesus' name I prayed and believed. Amen.
Amen. Thank you
Teacher,
so
I'm
much.
done.
Okay, thank you so much, Victoria. Thank you so much, everyone. Bye-bye. Let's meet at 2 for another session. Okay, bye, everyone.